Before the first storm even had a center, people had already given it a name. Across social media, the maps started spreading. Dark clouds over the Caribbean, red arrows bending toward the Gulf, satellite images with angry colors, titles warning that Arthur was forming, Arthur was coming, Arthur was already here. But there was one problem. There was no Arthur. No official tropical storm. No tropical depression. No closed circulation spinning over the water. No warning from the National Hurricane Center saying a named system had formed. The internet had already created the storm before the atmosphere had decided whether it wanted to build one. And that is where this story begins. Not with a hurricane, not with a landfall, not even with a tropical depression. It begins with something much bigger, much quieter, and much more important. Because while everyone was staring at the Caribbean, waiting for the first named storm of the 2026 Atlantic hurricane season, the atmosphere over North America had already started arranging itself into a pattern that could affect tens of millions of people at the same time. A pattern that could make one part of America feel like July, another part feel like April, another part feel like January, and another part feel like the tropics had been pulled hundreds of miles north. A pattern that could bring dangerous heat to the plains, chilly air to the northeast, strange cold aloft over California, flooding rains along the Gulf Coast, drought relief across the southeast, and eventually, maybe, a real chance for tropical development. All from one shape in the sky. And that shape has a name, an omega block. It is called that because when meteorologists look high above the ground, at the steering currents that control large-scale weather, the pattern can look like the Greek letter omega. A tall ridge of high pressure rises in the middle, while two lows dig down on each side. It looks like a wave that has been stretched, bent, and frozen in place. And that last part is the key. Frozen in place. Most weather moves. A front passes. A storm comes through. A ridge builds, then shifts east. A cold pocket drops south, then lifts away. But an omega block does not behave like ordinary weather. It slows the atmosphere down. It becomes a wall in the jet stream. It traps systems. It holds heat. It holds cold. It holds moisture. It forces the same regions to experience the same kind of weather again and again until the consequences start to stack. That is why this is not a normal early June pattern. This is not just a hot spell. Not just a rainy stretch. Not just a cool northeast weekend. Not just a strange satellite image over the Caribbean. This is one atmospheric machine showing different faces in different places. And the strangest part is that most people will not experience it as one story. They will experience it as separate headlines. People in North Dakota will read about heat and fire danger. People in New York and Boston will wonder why summer suddenly stepped backward. People in California will hear about unusually cold air aloft and late-season mountain snow. People in Texas and Louisiana will watch flood alerts light up their phones. People in Florida and the Southeast will see tropical moisture arrive after months of drought. And online, people will keep asking the same question, is this finally Arthur? But if you only follow the storm name, you miss the real event. Because the first storm may or may not form. The block already has. That is the warning. The atmosphere has already drawn the map. The pieces are already in place. And during the first days of June, the United States may not enter summer evenly. It may enter summer broken into different seasons at the same time. So tonight we are going to follow this pattern from the beginning. We are going to start with a quiet weather balloon rising into the sky near Washington, D.C., carrying a small instrument package that found something in the air that did not belong on the calendar. Then we will climb higher, into the steering level of the atmosphere, where the hidden omega shape begins to appear. From there, we will go west to the cold upper low over California. Then into the middle of the country, where the ridge is building heat like a lid over the plains. Then east, where the trough is dragging cooler air into the northeast. And finally, south, where the Bermuda high and deep tropical moisture are opening the door to flooding rain and perhaps, later, the first real tropical development window of the season. But before we talk about the storm that does not exist yet, we need to talk about the clue that proved something unusual was already happening. Because the first sign was not a hurricane hunter aircraft. It was not a dramatic radar loop. It was not a satellite image going viral online. It was a balloon, a simple weather balloon. And when it rose above Washington, D.C., it found August hiding inside May. Chapter 1. The Balloon That Found August in May. At 8 o'clock in the morning, the sky near Washington, D.C. did not look like the beginning of a national weather story. There were no dramatic waves crashing on a beach. No tornado sirens. No hurricane flags. No wall of fire racing across dry grass. No cars floating through floodwater. Just a routine weather balloon rising from near Dulles International Airport. It was the kind of thing that happens every day, so normal that most people never think about it. Across the country, weather balloons are launched on a schedule. They rise through the lower atmosphere, carrying small instruments that measure temperature, humidity, pressure, and wind. To the public, it looks boring. To forecasters, it is one of the most important truth checks in meteorology. Models can predict what the atmosphere should look like. Radar can show where rain is falling, satellite can show where clouds are forming, but a weather balloon touches the atmosphere directly. It climbs through the air layer by layer, collecting the facts. And on this morning, the facts were strange. The balloon measured a value called precipitable water. That sounds technical, but the idea is simple. Imagine the entire column of air above your head, from the ground to the top of the atmosphere, as a giant invisible sponge. Now imagine squeezing that sponge until every bit of water vapor inside it becomes liquid and falls to the ground. The depth of that water is the precipitable water value. It tells meteorologists how much moisture the atmosphere is carrying. And moisture matters because it is the fuel behind heavy rain, thunderstorms, and tropical downpours. The more moisture in the air, the more efficiently storms can produce rainfall. A dry atmosphere can generate clouds that look impressive but struggle to unload much water. A moisture-loaded atmosphere can turn ordinary thunderstorms into flood producers. Near Washington, D.C., in late May, the atmosphere is normally becoming warmer and more humid, but it is not usually fully tropical yet. The deep summer moisture usually arrives later. The thick, heavy, August-like air that feels like walking into a steam room is not supposed to dominate this early. But the weather balloon found something different. The air above the mid-Atlantic was loaded with moisture more typical of deep summer than late May. It was the kind of reading that makes a meteorologist stop scrolling, lean closer to the screen, and ask one question. Where did that come from? Because the atmosphere does not create that much moisture out of nowhere. Moisture has a source. It has a pathway. It has a steering pattern. And if tropical moisture is suddenly surging far north into places that are not supposed to be carrying that much water vapor yet, something larger must be moving it. This is where the story begins to widen. At first, it looks like a mid-Atlantic humidity story. A muggy day, thunderstorm fuel, maybe heavy rain, maybe a severe weather risk. But the balloon was not only measuring local humidity, it was revealing the first fingerprint of a continental pattern. Because at the same time that Washington's atmosphere was acting like August, South Florida was preparing for an even deeper moisture surge. The kind of moisture that can produce repeated thunderstorms, flooded streets, and rain rates that overwhelm drains in minutes. At the same time, the Gulf Coast was entering a wet corridor, with thunderstorms riding along boundaries and dropping heavy rain over areas already vulnerable to flooding. At the same time, the Southeast, which had been locked in drought for months, was about to receive the first meaningful moisture push in a long time. And at the same time, far away from all that tropical moisture, California was sitting under cold air aloft that looked wildly out of season. This is the first clue that the weather was not random. If one region is unusual, you can call it a local event. If two regions are unusual in opposite ways, you start looking at the pattern. But when the plains are heating like midsummer, the Northeast is cooling, the West Coast has winter-like air overhead, the Gulf is flooding, and the Caribbean is lighting up with moisture, you are no longer dealing with isolated events. You are dealing with structure. The balloon at Dulles had flown into one side of that structure. It had measured the moisture being pulled northward ahead of a cold front, supported by a high-pressure system over the western Atlantic. That high-pressure system, often called the Bermuda High, acts like a giant atmospheric pump when it is positioned correctly. Air flows clockwise around high pressure in the northern hemisphere. On the western side of that high, winds can move from south to north, dragging warm, humid air out of the tropics and toward the eastern United States. That is what the balloon found. Not a storm. A supply line. A river of moisture in the sky. But a supply line needs a reason to aim where it aims. It needs a steering environment. It needs other pressure systems around it. The Bermuda High was not acting alone. It was one of several anchors in a much larger setup. To the west, a ridge was building over the plains. Under that ridge, air was sinking, warming, and drying. That would become the heat dome. To the east, a trough was dropping through the Great Lakes and toward the mid-Atlantic. That would become the cool, unsettled side of the pattern for the northeast. To the far west, an upper low was spinning near California and the Great Basin. That would bring cold air aloft and late-season mountain weather to the west coast. Together, these features were shaping the flow of the atmosphere across North America. The balloon over Washington had simply flown through one of the places where the pattern was easiest to measure. And that is why the number mattered. It was not just high moisture. It was misplaced moisture. It was summer moisture arriving early, not because summer had simply started, but because the atmosphere had built a highway from the tropics into the eastern United States. When meteorologists saw that kind of moisture ahead of a front, they knew thunderstorms could become efficient rainmakers. A storm in that environment does not need to be huge to cause problems. If it moves slowly, or if several storms pass over the same place, rainfall totals can rise quickly. This is how flash flood risks appear before the public realizes anything unusual is happening. The sky might look cloudy. The air might feel sticky. People might think it is just another humid day. But above them, the atmosphere is carrying deep tropical water. and if the right trigger arrives, that water comes down. That trigger was already on the map. The eastern trough was pushing a cold front into the mid-Atlantic. Ahead of the front was warm, humid air. Behind it was cooler, drier air. Along the boundary between them, thunderstorms could fire, intensify, and move through populated areas. But again, the front was only one piece. The larger story was the block. The atmosphere had created a shape that was slowing the normal west-to-east movement of weather systems. Instead of quickly clearing out, the pattern was becoming stubborn. Moisture could keep feeding north. Heat could keep building in the middle of the country. Cool air could keep dropping into the east. The west could stay unsettled longer than expected. The weather balloon did not explain all of that by itself. But it gave us the first clue. A quiet instrument package rising above an airport near Washington had detected air that belonged to a different part of the season. And once you see that, the rest of the map begins to change. The question is no longer, why is it so humid today? The question becomes, what kind of atmospheric pattern can make late May behave like August in one place, January in another, and July somewhere else? The answer is hiding higher in the sky, at the level where the jet stream bends, at the level where ridges and troughs steer the weather, at the level where, if you draw the pattern across North America, the atmosphere begins to look like a Greek letter. Chapter 2. The Greek Letter over America. To understand what is happening, you have to leave the surface. Forget the thermometer on the porch for a moment. Forget the rain outside the window. Forget the viral hurricane maps and the daily forecast icons. Those are the symptoms. The cause is higher. Thousands of feet above the ground, the atmosphere moves in vast waves. These waves are not visible like ocean waves, but they shape almost everything people experience as weather. They guide storms. They open and close moisture pathways. They decide whether cold air drops south or warm air surges north. They determine whether a system races across the country in 2 days or sits in place until the ground below it starts to change. Usually these waves move from west to east. That is the normal rhythm of the mid-latitudes. A storm comes from the Pacific, crosses the west, moves through the plains, reaches the east, and exits into the Atlantic. Behind it, another system follows. The atmosphere behaves like a conveyor belt. But sometimes the belt slows down. Sometimes the wave gets stretched. Sometimes the atmosphere builds a ridge so strong in the middle that the flow cannot simply pass through. It has to go around. That is when a block can form. And when the block has a tall ridge in the center, with a low-pressure dip on each side, meteorologists call it an omega block, because the pattern resembles the Greek letter omega. It is one of the most important shapes in weather, not because it always produces the same conditions everywhere, but because it can produce different extremes at the same time. Think of it like a giant atmospheric dam. On one side, air piles up. On another side, moisture is forced along a boundary. Under the ridge, heat builds. Under the lows, cold air aloft lingers. Around the edges, storms can train, fronts can stall, and rainfall can repeat. The pattern does not just create weather, it traps weather. That is why this setup matters. The current North American pattern has several major anchors. The first anchor is over the west, where an upper-level low is spinning near California and the Great Basin. This is the cold side aloft. It lowers the heights in the upper atmosphere, cools the air above the ground, encourages clouds and showers, and can even support late-season mountain snow. The second anchor is the central ridge over the plains and upper Midwest. This is the heat engine. Air sinks under the ridge. Sinking air compresses. Compressed air warms. It also dries. That is why the plains can move quickly into dangerous heat and fire weather, while other parts of the country are wet or cool. The third anchor is the eastern trough, digging through the Great Lakes and toward the mid-Atlantic and northeast. This is the cool side for the eastern states. It helps push a cold front through the region, replacing humid air with cooler, drier, unsettled conditions. The fourth anchor is the Bermuda High over the western Atlantic. This is the moisture pump. Positioned correctly, it pulls tropical air northward from the Caribbean, Gulf, Bahamas, and western Atlantic into Florida, the Gulf Coast, the southeast, and eventually parts of the mid-Atlantic. These four pieces together are what make the pattern powerful. West, cold low. Center, heat ridge. East, trough and cool push. South and southeast, tropical moisture pipeline. Once you hold those four pieces in your mind, the entire weather map starts making sense. The plains are not randomly hot. They are under the ridge. The northeast is not randomly cool. It is under the eastern side of the block. California is not randomly chilly aloft. It is under the western low. The Gulf Coast is not randomly stormy. It is sitting along the moisture-loaded edge of the pattern. The Caribbean is not automatically producing a tropical storm, but it is feeding moisture into a setup that could later become more favorable. This is the key difference between a normal weather report and a real pattern story. A normal weather report tells people what will happen in their city. A pattern story tells people why different cities are experiencing different extremes at the same time. And right now, the why is the omega block. The ridge in the middle is the spine. Imagine it rising through the central United States like a wall. On the western side of that wall, the Pacific low is trapped. On the eastern side, the trough keeps dropping cooler air into the east. Along the southern edge, tropical moisture is pulled north and forced into boundaries where rain can become heavy. Under the ridge itself, the air bakes. That is why blocks are so frustrating for forecasters and so important for everyone living under them. They do not behave like quick-moving systems. They linger. A normal front moves through and clears the air. A block can keep the same general setup alive for days. This means the first storm may not solve the problem. The first round of rain may only saturate the ground for the next round. The first day of heat may only begin the stress that becomes dangerous by day 4 or 5. The first red flag warning may not be the end of fire weather. It may be the beginning of a multi-day fire window. That persistence is the real danger. On a map, the Omega block can look elegant. A wave, a ridge, 2 dips, a recognizable shape. On the ground, it can feel chaotic. In one region, people are checking air conditioners. In another, they are canceling beach plans because the wind is cool and clouds are low. In another, mountain roads face late-season snow showers. In another, emergency managers are watching streams rise. In another, people are looking at satellite images and wondering if the season's first tropical storm is being born. But the atmosphere is not confused. It is organized. The organization is simply large enough that it creates opposite results in different places. This is what makes a blocking pattern so difficult for the public to understand. People naturally interpret weather locally. If it is hot where they live, they assume the story is heat. If it is raining where they live, the story is flooding. If it is cool, the story is delayed summer. If a storm is on satellite, the story becomes the tropics. But the atmosphere is not divided into headlines. It is connected. The same ridge that helps produce heat in the plains can help steer moisture into the southeast. The same trough that cools the northeast can provide the boundary needed for storms. The same western low that keeps California cool can help support the larger wave shape that prevents the whole pattern from moving along. Everything is connected through the flow. That is why the Greek letter matters. The omega shape is not just a symbol. It is a map of control. It tells us that the normal movement of weather has slowed. It tells us that extremes can last longer. It tells us that the first days of June may not behave like a clean transition into summer. And it tells us why the internet may be looking in the wrong place. Because people are focused on the possible storm in the Caribbean. But the Caribbean is only one piece of the pattern. The bigger question is not whether Arthur forms today. The bigger question is whether the block holds long enough to keep feeding moisture, heat, cool air, and instability into the same regions again and again. If it does, then the first 2 weeks of June will be remembered differently depending on where people live. For the plains, it may be remembered as the first dangerous heat event of the season. For the Northeast, it may feel like summer was postponed. For California, it may be the strange week when the upper atmosphere looked more like winter. For the Gulf Coast, it may be a flood corridor. For the Southeast, it may be the first real drought relief in months. For the tropics, it may be the opening act of the hurricane season. One pattern, 5 faces. And the next question is the most important one. Why does this kind of pattern matter more than an ordinary ridge or trough? The answer is persistence. Because in weather, the most dangerous events are often not the ones that hit hardest for 1 hour. They are the ones that refuse to leave. Chapter 3. When the jet stream gets stuck. The atmosphere is always moving, but it does not always move freely. Sometimes it hesitates. Sometimes it bends into a shape so large and stubborn that the normal rhythm breaks down. And when that happens, weather stops behaving like a passing event and starts behaving like a trap. That is the difference between ordinary weather and a blocking pattern. A normal ridge of high pressure can make a place hot and dry for a few days. People notice it. They complain about the heat. Maybe the grass dries out. Maybe power demand rises. Then the ridge shifts east, a front comes through, temperatures drop, and the atmosphere resets. A block is different. A block does not reset quickly. It holds. And when weather holds, consequences build. This is the part that matters most. Extreme weather is not only about intensity, it is also about duration. 1 hot afternoon can be uncomfortable. 5 hot afternoons in a row can become dangerous. 10 hot afternoons can become a public health emergency, especially early in the season when people are not acclimated and homes may not yet be prepared for sustained heat. 1 thunderstorm can flood a street. But several rounds of storms moving over the same region can saturate the ground, fill creeks, overwhelm drainage systems, and turn later storms into flash flood producers, even if those later storms are not stronger than the first. 1 dry, windy afternoon can raise fire danger. But a multi-day stretch of heat, low humidity, and gusty winds can drive vegetation further and further until the landscape becomes ready to burn from a single spark. This is why the Omega block is more important than any single daily forecast. It is not just what happens. It is how long the atmosphere keeps the door open for it to happen again. The jet stream is central to this. It is the fast-moving river of air high above the ground that guides storms and separates colder air to the north from warmer air to the south. In a typical pattern, the jet stream carries disturbances across the continent. Weather changes. Systems move. Regions get breaks, but during a high-amplitude block, the jet stream bends sharply. It may arc far north around the central ridge, then dive south around the troughs on either side. The wave becomes large. The flow slows. The ridge becomes a wall. The lows become trapped around it. That is what creates the strange national contrast. In the center of the ridge, the air sinks and warms. Heat builds day after day. On the cool side of the troughs, air from higher latitudes can drop south and stay longer than expected. Along the edges, where warm and cool air masses meet, storm zones can set up repeatedly. And near the south and southeast side of the pattern, tropical moisture can be pulled northward like water through a hose. This is how the same blocked jet stream can produce heat, chill, fire weather, flooding rain, and tropical moisture at the same time. It is not contradiction. It is structure, and the structure becomes more dangerous when it persists. Think of the block as a hand pressing down on the weather map. Under the palm, the plains heat up. Around the fingers, storms form. Along one edge, cool air slides south. Along another edge, tropical moisture is pulled north. The hand does not need to squeeze harder every day. It only needs to stay there. That is when the surface starts to respond. Soil moisture changes. Vegetation dries. Rivers rise. Human bodies accumulate heat stress. Reservoirs respond slowly. Roads flood more easily. Fire fuels become more sensitive. Agriculture begins to feel the pattern not as weather, but as pressure. The public often notices weather only when it becomes dramatic. A tornado warning. A named storm. A flood rescue. A wildfire. A record high temperature. But meteorologists often see the danger earlier because they watch the setup. They know when a pattern is creating repeated opportunities. They know when a ridge is not moving. They know when a boundary is likely to stall. They know when moisture values are too high for the date. They know when a region has become vulnerable before the biggest impact arrives. That is exactly what makes the current pattern concerning. The first signs are already scattered across the map. The mid-Atlantic moisture reading that looked more like August. The heat building across the northern plains. The dry winds and low humidity in fire-prone areas. The cold upper low over California. The flood corridor forming from Texas into the Gulf states and toward the Appalachians. The Caribbean moisture surge that is not yet a tropical storm but is part of the same pattern. Each sign is a clue. Together, they show a continent under a stretched and slowed atmosphere. This is also why comparing one city's weather to another becomes so revealing. If one location is 100 degrees and another location at a similar latitude is in the 70s, that is not just a local difference. That is a sign of a strong temperature gradient. And strong gradients are often where the atmosphere stores energy. Temperature gradients help power storms. Moisture gradients help focus rainfall. Pressure gradients help create wind. When a block sharpens these gradients and holds them in place, it does not produce calm weather around its edges. It produces active zones. That is why the Gulf Coast can face heavy rain while the plains face fire danger. That is why the Northeast can be cool while the northern plains bake. That is why the tropical moisture surge can be real even while the named storm rumors are false. The block is not one kind of weather. It is a pattern that organizes many kinds of weather. And as the first days of June unfold, the most important question becomes simple. Does the block weaken quickly, or does it hold? If it weakens quickly, the pattern may relax. The heat may shift. The cool air may retreat. The rain corridor may become less focused. The tropical development window may narrow. But if it holds, then each regional impact has time to become more serious. The plains' heat can peak. Fire danger can expand. The Northeast can stay unsettled. The Southeast can receive repeated rounds of rain. Flood risk can grow in saturated areas. The Caribbean and Gulf can remain moist and disturbed long enough for a tropical system to at least have a chance. That is why this is not just a forecast. It is a waiting game. The atmosphere has built the shape. Now the question is how long the shape survives. And the first region where that persistence becomes impossible to ignore is the middle of the country. Because under the ridge, the air is sinking. The ground is drying. The heat is building. And in places that are not supposed to feel like midsummer yet, the thermometer is about to start telling a different story. Chapter 4. The Plains Under the Heat Dome. In western North Dakota, heat does not arrive quietly when the land is dry. It comes with wind. It comes with low humidity. It comes with grass that bends under gusts and fields that have already lost too much moisture. It comes with a sky that looks empty, which can be the most dangerous look of all, because under a ridge, the atmosphere often appears calm while the ground below it becomes more flammable by the hour. This is the face of the omega block that is easiest to feel on human skin. The heat dome. Under the central ridge, air sinks from higher levels of the atmosphere toward the ground. As it sinks, pressure increases. The air compresses. When air compresses, it warms. At the same time, the relative humidity drops, because warmer air can hold more moisture before it feels saturated. So the same process creates both heat and dryness. That combination is what makes the plains so vulnerable during this pattern. This is not the humid, heavy heat of the Gulf Coast. This is the dry, windy, exposed heat of open country. The kind of heat that can turn ordinary outdoor work into a health risk and ordinary fire danger into a serious threat. Across parts of eastern Montana, western North Dakota, South Dakota, and the upper Midwest, temperatures are expected to climb far above what people normally expect this early in the season. In some locations, readings near 100 degrees become possible around the opening days of June. That number matters because of where it is happening. A 100-degree reading in midsummer in Texas is not unusual. A 100-degree reading in parts of the northern plains near the beginning of June is a different kind of signal. It means the ridge is strong. It means the atmosphere is not gently easing into summer. It is forcing summer northward ahead of schedule, and early season heat is often more dangerous than the same heat later in the year. By late July, people have adjusted. Homes have been running cooling systems for weeks. Outdoor workers have changed routines. Bodies have built some acclimation, but early heat catches people in transition. The body is not ready. The routines are not ready. The infrastructure may not be fully prepared. People underestimate it because the calendar tells them it should not be that serious yet. That is how heat becomes dangerous. Not only because of the temperature itself, but because people fail to respect it early enough. The heat risk is especially important for older adults, people with health conditions, outdoor workers, farmers, ranchers, construction crews, and anyone without reliable access to cooling. In rural areas, the distance between people can make heat illness more dangerous. Someone working alone outdoors may not have help nearby when symptoms begin. And heat is only one part of the plains story. The second part is fire. When temperatures rise into the 90s, humidity falls into the teens, and winds gust strongly during the afternoon, fire weather can escalate quickly. The land does not need to be a forest to burn dangerously. Grasslands can burn fast. Agricultural fields can burn fast. Brush, roadside vegetation, and dry prairie can carry fire with frightening speed when wind is behind it. This is why red flag warnings matter. They are not just another weather alert. They mean the atmosphere and the landscape have reached a combination where fires can start easily and spread rapidly. A spark from equipment, a vehicle, a power line, a careless burn, or lightning can become a much larger problem than it would on a cooler, calmer, more humid day. And under a block, the danger can repeat. One afternoon of critical fire weather is serious. Several afternoons in a row are more serious. Each day of heat and dryness pulls more moisture from vegetation. Each windy afternoon stresses the landscape again. If a fire does not start on day 1, the ingredients may still be there on day 2, day 3, and day 4. That is why the ridge is not just a heat producer. It is a risk multiplier. The middle of the country is also important because it shows how extreme the national contrast has become. While the plains heat up under the ridge, the northeast sits on the cooler side of the eastern trough. Cities at roughly similar latitudes can experience wildly different temperatures during the same period. That contrast is not random. It is the omega block revealing itself at the surface. The ridge holds heat in one region. The trough holds cooler air in another. Between them, the temperature gradient sharpens. And where gradients sharpen, the atmosphere often becomes more active. But in the heart of the ridge, the story is suppression. Clouds struggle, rain chances drop, sun dominates. The ground keeps heating, and the longer the ridge holds, the more the heat builds into daily life. Farmers watch soil moisture, ranchers watch livestock, fire managers watch wind and humidity, energy providers watch demand. Parents watch children playing outside. Outdoor workers watch the clock, because the difference between morning and afternoon can become the difference between manageable and dangerous. This is the human side of a heat dome. It is easy to describe it as a weather map feature, a ridge, a high-pressure area, a warm anomaly. But on the ground, it becomes decisions. Do we move work earlier in the day? Do we cancel practice? Do we check on elderly neighbors? Do we delay machinery use because sparks are dangerous? Do we prepare for fire response? Do we open cooling centers? Do we treat this like summer even though summer has barely started? That last question may be the most important, because the atmosphere does not wait for the calendar. If the ridge brings July conditions in early June, then people have to respond to July conditions in early June. This is where the phrase heat dome can sometimes mislead people. It sounds like something dramatic that appears all at once, like a lid dropped over the country. But the real danger often builds gradually. A warm day becomes a hot day. A hot day becomes a record-challenging day. A dry afternoon becomes a fire weather warning. A few alerts become a regional risk. By the time the public notices, the atmosphere may have been setting the stage for days. And while the plains are dealing with heat, the rest of the block keeps working. To the west, California remains under colder air aloft. To the east, the trough keeps the northeast cooler and unsettled. To the south, the moisture corridor keeps sending rain into the Gulf Coast and southeast. The heat dome is not isolated. It is the central pillar holding much of the pattern in place. If that ridge weakens, the pattern changes. If it holds, the consequences continue. And for the plains, that means the first week of June may feel less like the beginning of summer and more like a warning shot from the middle of it. The ridge is building, the air is sinking, the humidity is dropping, the wind is rising, and in the heart of the continent, one spark may be enough. Chapter 5. The Northeast on the Wrong Side of Summer. While the plains are heating up, the Northeast is stepping into a different season. Not winter, not a true cold snap, but something that feels wrong for the calendar. The air turns cooler, the clouds return, showers become possible. The humidity drops behind the front. People who were ready for early summer suddenly find themselves reaching for a light jacket, checking weekend plans, and wondering why June feels like it arrived with the brakes on. This is the other side of the Omega Block, the cool side, and it is just as connected to the pattern as the heat dome over the plains. The eastern trough is responsible. It dips down through the Great Lakes and into the eastern United States, dragging a cold front through the mid-Atlantic and helping cooler air slide south from Canada. Ahead of that front, the atmosphere is warm, humid, and unstable. Behind it, the air is cooler, drier, and more unsettled. That boundary is important because it marks the transition between two different air masses. Before the front passes, places along the I-95 corridor can feel tropical. The air is thick, moisture values are high. Thunderstorms can become strong or heavy because the atmosphere has so much water available. Then the front moves through. The wind shifts. The humidity falls. The temperature drops, and the mood of the weather changes. This is not the kind of cold that damages crops or shocks the power grid. It is more subtle than that. It is a seasonal delay. The kind of pattern that makes people say it feels more like April or May than June. And that matters because weather is emotional as much as physical. By early June, people expect a certain rhythm: outdoor dining, beach plans, graduation events, baseball games, evening walks, windows open at night, the first reliable taste of summer. But under this pattern, the Northeast does not get a clean summer arrival. It gets cool air, clouds, showers, and a feeling that the season has paused. Cities like New York, Boston, Philadelphia, Pittsburgh, and Washington can all feel the influence of the eastern trough in different ways. Some places may see brief warm periods ahead of disturbances. Others may stay cooler and cloudier. Some may see showers from passing systems dropping down in the northwest flow behind the front. But the broader theme is the same. The Northeast is on the wrong side of summer. What makes this especially striking is the contrast with the plains. While parts of North Dakota and Montana may approach dangerous heat, parts of the Northeast and Mid-Atlantic can remain much cooler. That temperature difference across the same country during the same week is one of the clearest surface signatures of the block. It is like the continent has been split. One side gets early summer heat, the other gets delayed summer chill. And between those regions, the atmosphere stores energy along boundaries that can help produce storms. The severe weather risk along the front is part of this transition. When warm, humid air ahead of the front meets cooler, drier air behind it, thunderstorms can develop. If the wind profile and instability are strong enough, some storms can produce damaging wind gusts. But after the storms, the bigger story becomes persistence. The cool side does not simply vanish overnight if the block holds. Disturbances can continue to rotate through the eastern trough. Clouds can redevelop, showers can return. Temperatures can stay below normal or near the cool side of normal for several days. That is how the pattern becomes noticeable to ordinary people. Not because one afternoon is chilly, but because the days begin to feel repetitive. Gray morning, cool breeze, showers possible. Brief sun, another disturbance. Another cool night. Another forecast that looks more like late spring than early summer. In coastal areas, there can be another concern: water hazards. People often associate beach danger with hot days and tropical storms, but rip currents and rough surf can happen in cooler patterns too, especially when winds and swell line up in dangerous ways. Early season beachgoers may underestimate the risk because the weather does not look dramatic. That is one of the quiet dangers of this setup. Not every hazard announces itself with a dark sky. Some arrive through assumptions. People assume early June means safe beach weather. They assume cool air means lower risk. They assume no named storm means no coastal danger. But the atmosphere does not follow those assumptions. A blocked pattern can create hazards that feel out of place. Cool air with beach risk, heavy rain without a tropical storm, fire danger far from the desert, winter-like air aloft near the start of summer. The Northeast chapter of this pattern is important because it proves the block is not only about heat. A heat dome by itself would be easier to understand. One region gets hot. End of story. But this setup is more complex. The same pattern that is forcing heat into the central United States is forcing cooler air into the east. The same shape that is producing fire weather on one side is helping create showers and thunderstorm chances on another. That is why calling it weird weather is not enough. It is not random weirdness. It is organized contrast. And organized contrast is one of the atmosphere's most powerful tools. Where air masses differ strongly, weather happens. Where moisture pools, rain intensifies. Where ridges stall, heat grows. Where troughs linger, cool, unsettled patterns repeat. The Northeast is living under that lingering trough influence. For residents, the practical message is simple. Do not assume the first week of June will behave like summer just because the calendar changed. Expect cooler stretches. Expect showers. Watch for thunderstorms near frontal boundaries. Along the coast, pay attention to marine and rip current alerts, even if the day does not feel especially hot. But the larger message is bigger. The Northeast is one face of the same national pattern. It is not separate from the plains heat. It is not separate from the California upper low. It is not separate from the Gulf Coast rain corridor. It is not separate from the Caribbean moisture surge. It is the eastern side of the omega block doing exactly what the eastern side of an omega block does. It pulls the atmosphere backward. It delays summer. It keeps the pattern unsettled. And as long as the block remains in place, the Northeast will continue to feel like it is watching summer happen somewhere else. Because in a way it is. Summer is exploding over the plains. Tropical moisture is surging into the south. Cold air aloft is lingering in the west. And the Northeast is trapped beneath the cool bend of a jet stream that has stopped moving normally. The country is not entering one season. It is entering several at once. And the reason is still the same. The atmosphere is blocked. Chapter 6, California's January air in late May. On the other side of the country, the atmosphere is telling the opposite story. While the plains are heating up under a ridge that feels like midsummer, California is sitting beneath air that does not belong anywhere near the start of June. Not at the surface only. Higher up, at the level where forecasters watch the steering currents of the atmosphere, the West Coast is under the influence of an unusually cold upper-level low. And that matters because the weather people feel on the ground often begins thousands of feet above their heads. To most people, the sky over California may simply look cloudy, breezy, unsettled, or cooler than expected. Along parts of the coast, the marine layer may feel stubborn. In the valleys, temperatures may struggle compared to where they should be this close to meteorological summer. In the mountains, showers may develop. At the highest elevations, late-season snow can still appear. But to a meteorologist looking at the upper air map, the message is sharper. The atmosphere over California looks like it has slipped backward on the calendar. That is the strange part. The end of May is supposed to be a transition point. The coldest upper lows of the winter season are usually fading. Heights aloft usually begin to rise. The jet stream usually starts pulling north. The West Coast still gets cool days, marine layers, and late-season systems, but the overall direction should be towards summer. Instead, the western side of the Omega Block has carved out a cold pocket aloft and allowed it to sit. This is one of the major anchors of the entire pattern. Remember the shape. A ridge in the middle, a trough or low on the west side, a trough on the east side. That western low is the reason California and parts of the Great Basin are experiencing weather that feels out of season. The central ridge over the plains acts like a wall, blocking the normal west to east progression. The upper low cannot simply move across the country like an ordinary system. It slows, it spins, it lingers, and every day it lingers, the west stays under its influence. This is why the same country can have near 100-degree heat in the northern plains, while parts of California are dealing with temperatures far below normal for late May. The atmosphere is not confused. It is divided by the block. Under the western low, cold air aloft creates instability. That does not always mean severe storms, but it can mean clouds building over higher terrain, showers popping up, and snow levels lowering enough for late-season mountain snow in places that still have enough moisture and elevation. For the Sierra Nevada, late May snow is not impossible. The highest elevations can still see snow late in the season, but the symbolism matters because of the year around it. Much of the West has been dealing with drought stress and poor snowpack conditions. A late burst of mountain snow may look dramatic on camera, but it does not automatically repair a water year that has already gone wrong. That distinction is important. A snowy scene in the Sierra can become a viral image. It can look like the drought is suddenly over, but hydrology does not work that way. Western water problems are built over months, sometimes years. Snowpack, reservoir levels, soil moisture, groundwater, and seasonal runoff all matter. A late May snow event can add a little water to the system, but it cannot reverse an entire dry season by itself. So the West Coast chapter of this pattern has two sides. It is meteorologically dramatic because the upper-level cold is so unusual for the date. But it is not a miracle solution for the Western drought picture. It is a symptom of the block, not a rescue. For Southern California, the impacts may be more about feel than crisis. Cooler temperatures, more clouds, breezy conditions, a pattern that feels more like the Pacific Northwest than late spring in Los Angeles. Coastal areas can remain gray. Valleys can run below normal. Mountain and desert zones can feel the wind more sharply. For the Pacific Northwest, the same broad pattern can support clouds, showers, and cooler than expected conditions. Moisture rotating around the upper low and onshore flow can keep the region unsettled. The weather may not be historically extreme in every city, but the synchronization with the larger block is what matters. The West is not having a random cool spell. It is holding down the western leg of the omega. That western leg helps keep the entire atmospheric shape alive. And this is where the story becomes important for people far from California. If the western upper low weakens quickly and moves away, the block may begin to loosen. The whole structure can start transitioning toward a more normal flow. The ridge can relax. The temperature contrast can narrow. The flood corridor can become less focused. But if the upper low stays strong, the pattern has support. The atmosphere remains blocked. The plains heat continues. The east remains under trough influence. The southern moisture pipeline keeps feeding rain chances. The Caribbean and Gulf remain watched for potential organization later. In other words, what happens over California helps determine what happens across the rest of the country. That is why meteorologists pay attention to upper-level lows even when the surface impacts seem modest. A cold low over California is not only a California story. In a blocked pattern, it is one pillar of a continental structure. And that structure is controlling the first days of June. This is also why the national weather map can look so strange. The western United States is dealing with cold air aloft and possible mountain snow. The central United States is baking. The eastern United States is cooling behind a front. The south is turning wet. The Caribbean is feeding moisture north. If you look at each region separately, it feels chaotic. If you look at the upper air pattern, it becomes clear. The atmosphere has built a giant wave and then slowed it down. California is under the left-hand dip of that wave. The plains are under the crest. The northeast is under the right-hand dip. The Gulf Coast and southeast are under the moisture channel wrapping around the southern side. That is the omega block. And California's January-like air aloft is one of the clearest signs that the block is not weak. It is deep enough to reach across the continent. It is strong enough to split seasons. And it is stubborn enough that its consequences are not ending in one afternoon. So when people in California look outside and see clouds, cool air, wind, or mountain showers, they may not realize they are looking at the same pattern that is also pushing heat into North Dakota and moisture into Florida. But they are. One side of the country is under the cold pocket. One side is under the heat ridge. One side is under the trough. One side is under the tropical feed. Different weather, same machine. And as the western low begins to drift, weaken, or hold, forecasters will be watching carefully. Because the future of the block depends partly on whether this cold anchor stays in place. For now, California is the winter-like face of an early summer pattern. And the next face is the wet one. Because while the west looks backward toward January and the plains leap forward into July, the southern edge of the pattern is opening a corridor of rain from Texas to the southeast. A corridor where the atmosphere does not need a named storm to flood roads, creeks, and neighborhoods. Chapter 7. The Gulf Coast Rain Machine. The rain does not need a name to become dangerous. That is one of the most important truths of this entire pattern. People often wait for a tropical storm name before they start paying attention. They hear Arthur or Barry or Cristobal, and suddenly the weather feels official. Suddenly the threat feels real. Suddenly they check supplies, watch updates, and take flooding seriously. But water does not wait for a name. A thunderstorm complex can flood a city without ever becoming tropical. A stalled boundary can drop inches of rain without a closed circulation. A moisture surge from the Caribbean can turn streets into rivers even while the National Hurricane Center says no tropical cyclone is expected. And that is exactly why the Gulf Coast rain corridor matters. From Texas toward Louisiana, Mississippi, Alabama, the Florida Panhandle, and eventually parts of the Southeast, the atmosphere has built a pathway for repeated heavy rainfall. This is the southern face of the Omega Block, and it may become one of the most visible faces because it produces the kind of weather that appears on phones as alerts. Flash flood warning, flood advisory, severe thunderstorm warning, special weather statement, flood watch. These alerts become the public language of the pattern. But underneath the alerts, the mechanism is larger. The central ridge over the plains is not only creating heat under itself. Along its southern and southeastern edge, the flow helps focus moisture and instability. At the same time, the Bermuda High over the western Atlantic helps pull tropical moisture northward. That moisture spreads into the Gulf Coast states and interacts with boundaries left behind by fronts, outflow from previous storms, and upper-level disturbances moving around the block. This is how a rain machine forms. Not one storm, a repeating setup. The first round of storms wets the ground. The second round has less capacity to soak in. The third round runs off faster. Creeks rise, ditches fill, low water crossings become dangerous. Urban drainage systems struggle. And then, if storms begin training, the situation can escalate quickly. Training storms are one of the most dangerous rainfall patterns because they move like train cars over the same track. One storm passes, Then another follows the same path. Then another. Each individual storm may not seem historic, but together they stack rainfall over the same neighborhoods, roads, fields, and streams. That is how flash flooding surprises people. They see rain, then heavy rain, then water on the road, then the road is gone. This pattern is especially concerning because some areas are already wet from recent rainfall, while others are drought-stressed and may not absorb the first heavy downpour efficiently. That means different counties can experience the same rain very differently. In one place, rain becomes useful drought relief. In another, it becomes runoff and flooding. In another, it does both. Texas is often one of the first places to reveal this kind of setup. The state sits at the meeting point of Gulf moisture, dry line boundaries, old storm outflows, hill country terrain, and strong spring-to-summer instability. When a slow-moving line of thunderstorms develops, especially near corridors like I-35 or across the hill country, rainfall can become dangerous fast. The hill country is particularly vulnerable because water moves quickly over terrain. Creeks can rise with little warning. Roads can flood before people realize how much rain has fallen upstream. A storm that looks manageable on radar can become dangerous if it parks over the wrong watershed. Farther east, southeast Texas and the Houston area face a different kind of vulnerability. Urban flooding. When rainfall rates exceed what drainage systems can handle, water backs up on streets, underpasses, and neighborhoods. In a moisture-loaded environment, rainfall rates can become intense enough that even a short storm creates problems. Then the corridor extends. Louisiana, Mississippi, Alabama, the Florida Panhandle, the Tennessee Valley, the Lower Ohio Valley, parts of West Virginia, and the Central Appalachians. The rain corridor does not behave like a single line on a map. It shifts. It pulses. It follows boundaries. It forms clusters. Some areas get missed while others get hit repeatedly. That uncertainty can make the forecast frustrating. A model may show several inches of rain across a broad region, but the real danger depends on where the heaviest storms train. One town may get a manageable inch. Another town nearby may get 5 inches. Another may flood because rain falls upstream, not directly overhead. That is why flash flood forecasting is so difficult. The atmosphere can tell us the ingredients are present. It can tell us the corridor is favored. It can tell us the moisture is deep. It can tell us the pattern supports repeated storms. But the exact street that floods may not be clear until storms are already forming. This is why people in the corridor need to treat repeated rain chances seriously, even if no tropical system exists. Again, the absence of Arthur does not mean the absence of danger. The Gulf Coast rain machine is already a real threat, and it is connected to the same block that is producing heat and fire danger far away. This contrast is one of the strangest parts of the pattern. While the plains dry out under heat and wind, the Gulf Coast receives moisture in excess. While one region worries about sparks, another worries about water. While one area needs rain desperately, another gets too much too fast. The atmosphere is creating opposite emergencies at the same time, and that is one of the signatures of a high-amplitude block. The southern rain corridor also matters because of what comes next. The same moisture-feeding thunderstorms across the Gulf states is connected to the deeper tropical moisture over the western Caribbean and Gulf. That does not mean a tropical storm is forming now, but it does mean the environment is becoming rich with moisture, disturbed weather, and broad low-level energy. Those are pieces that forecasters watch early in hurricane season. Most early-season tropical systems do not form from perfect textbook waves rolling off Africa. They often form closer to home, the western Caribbean, the Gulf of Mexico, the Bay of Campeche, old frontal boundaries, broad gyres, messy clusters of storms, or areas where tropical moisture sits long enough to organize. That is why this rain corridor is not separate from the tropical question. It is the bridge between ordinary thunderstorms and the possibility of something more organized later. For now, though, the immediate concern is rain. Not wind, not surge, not a named storm. Rain. Rain on saturated ground. Rain over dry ground that cannot absorb it quickly. Rain falling repeatedly along boundaries. Rain that can turn roads dangerous before the evening news has even explained the setup. The practical advice is simple but serious. Do not drive through flooded roads. Do not assume a familiar crossing is safe. Do not wait for a tropical storm name to respect flash flood warnings. If alerts come through, treat them as real. Water depth is hard to judge, especially at night, and it takes less moving water than most people think to carry a vehicle. This is the Gulf Coast face of the Omega Block. It is loud, wet, and dangerous in a completely different way from the plains heat, and yet it comes from the same atmospheric machine. The ridge holds. The moisture feeds north. The boundaries stall. The storms repeat. And as the rainfall spreads into the southeast, the story changes again. Because some of the places about to receive heavy rain have been waiting for rain for months. But when drought relief arrives through thunderstorms, it does not always arrive gently. Chapter 8. Drought relief with a flood warning attached. For months, parts of the southeast have been waiting for the sky to change. Fields have dried, lawns have browned, streams have run low, reservoirs have dropped. Farmers have watched soil moisture disappear from the ground and hope disappear from the forecast. In a long drought, every cloudy day becomes a question. Will it rain this time? Will this storm miss again? Will the next system finally bring something meaningful? And then, after so many disappointing forecasts, the atmosphere finally opens the door. Moisture arrives, thunderstorms become more widespread, rain chances climb. The pattern flips. But the relief does not come as a gentle, steady, soaking rain across every county. It comes through a tropical moisture surge. It comes through thunderstorms. It comes through downpours. It comes with the possibility of flash flooding. That is the complicated truth of this southeast rain event. It is good news. And it is dangerous. Both can be true at the same time. The southeast has been dealing with serious drought stress. In places like Georgia, Alabama, South Carolina, North Carolina, and parts of Florida, a long dry stretch has affected soil moisture, agriculture, vegetation, water supply, and regional fire concerns. When drought lasts long enough, it becomes more than a weather problem. It becomes an economic problem, an agricultural problem, a water management problem, and a daily anxiety for people who depend on the land. So when the forecast finally shows multiple days of rain, it matters. This is not just another wet week. For some places, it may be the first meaningful rainfall pattern in a long time. The moisture source is tropical. Flow from the south and southwest helps pull moisture from the Caribbean, the Gulf, and the western Atlantic into the region. The Bermuda High plays a role by pumping moisture northward, while the larger block keeps the pattern from quickly clearing out. That is why rain chances can remain elevated for several days. The atmosphere is not just giving the southeast one storm, it is giving it a moisture regime. And for drought relief, duration matters. A single thunderstorm may wet the surface, but repeated rainfall over several days can begin to change soil moisture, increase stream flow, and slowly feed water systems. But here's the problem. Drought changes the ground. When soil becomes very dry, it does not always absorb heavy rain efficiently at first. The surface can harden. Water can run off before it soaks in. Instead of acting like a sponge, the ground can behave more like pavement during the first burst of heavy rain. That creates a strange situation. A drought-stricken area can flood. People sometimes hear drought and assume flooding is impossible. But drought and flash flooding are not opposites. In fact, dry, compacted ground can sometimes increase runoff during intense rainfall. If rain falls too fast, the land cannot take it in. So the first wave of rain may produce less drought recovery than the radar suggests. Some water runs off into creeks and drains. Some causes street flooding. Some fills low spots. Only part of it enters the deeper soil profile. Then, if more rain comes later, the ground may absorb better. The first round softens the surface. The second and third rounds may begin doing more useful hydrological work. But that process takes time. This is why a drought does not end the moment heavy rain appears on radar. Reservoirs also respond slowly. A reservoir does not rise simply because a city receives rain. It depends on where rain falls within the watershed, how much runs off, how much is absorbed, how much is intercepted by vegetation, and how water managers handle releases and storage. A major rain event can help, but water systems recover on a different clock than thunderstorms. That is why the Southeast's rain story must be told honestly. This rainfall may be meaningful. It may begin to crack the drought. It may improve topsoil moisture. It may help stressed vegetation. It may reduce short-term fire concerns in places that receive repeated rain. It may provide psychological relief after months of dry forecasts, but it will not automatically erase long-term drought. And it may cause flooding while it helps. This is why the phrase drought relief with a flood warning attached fits the moment. For Florida, the wet pattern can arrive forcefully. South Florida often handles tropical downpours as part of its warm season rhythm, but very high moisture values can still overwhelm urban areas. When rain rates become intense, even places used to heavy rain can flood. Streets pond, canals rise, poor drainage areas become trouble spots. For Alabama and Georgia, repeated thunderstorms can bring more widespread relief, but also localized flooding where storms train. For the Carolinas, the benefits depend heavily on where the rain bands set up. Some areas may receive multiple inches. Others may get less. Drought recovery will be patchy. For farmers, the rain is both welcome and nerve-wracking. Too little rain fails to help. Too much rain too quickly can damage fields, delay planting, wash out young crops, or increase disease pressure. The perfect drought relief rain is slow, steady, and widespread. This pattern may instead deliver bursts, downpours, and uneven totals. That does not make it useless. It makes it complicated. And that complication is exactly what the Omega Block is producing across the country. In the plains, the block creates too much heat and dryness. In the southeast, it pulls in the moisture that can finally bring rain. But because the moisture is arriving through convective storms, the same rain that helps can also harm. The atmosphere often works this way. It solves one problem by creating another. Drought relief comes through flood risk. Heat relief may come through severe storms. Tropical moisture may feed both reservoirs and road closures, and early season rain may reduce fire danger in one region while another region burns under the ridge. This is why people must avoid simple interpretations. Rain is not automatically safe because drought exists. No named storm does not mean no flood risk. A wet week does not mean a drought is over. A flood warning does not mean the rainfall has no benefits. Everything depends on amount, intensity, location, duration, soil condition, and what comes next. The Southeast is entering a pattern where all those factors matter. The first days of June may bring the most meaningful moisture signal in months to some areas. That is important. But the delivery method is not calm. It is tropical, unstable, and uneven. And this wet pattern also sets the stage for the next question. Because the same deep moisture that brings drought relief is connected to the larger disturbed area over the Western Caribbean and Gulf. The internet is already calling it a storm. The atmosphere has not done that yet. But the moisture is real. The rain is real. The setup is real. And the next step is understanding why a moisture surge can look like a tropical storm without actually being one. Chapter 9. The Caribbean Disturbance That Is Not Arthur. From space, the Western Caribbean can look dramatic even when no tropical storm exists. Clouds explode upward in bright white clusters. Thunderstorms flare during the heat of the day. Moisture streams northward toward the Gulf. Satellite loops show movement, rotation-like curves, and bursts of convection that look powerful when color-enhanced. To someone scrolling quickly on a phone, it can look obvious. Something is forming. Something is spinning. Something has a name. But the atmosphere is more complicated than a satellite thumbnail. A tropical storm is not born simply because clouds look angry. A tropical cyclone needs structure. It needs a closed circulation near the surface. It needs persistent thunderstorms organizing around that center. It needs pressure falls. It needs a warm core structure. It needs the surrounding environment to support organization instead of tearing it apart. Without those ingredients, the system may look impressive and still not be a tropical storm. That is the key to understanding the Western Caribbean situation. There is moisture. There are thunderstorms. There is disturbed weather. There may be broad lower pressure or messy turning in parts of the region. But that is not the same as a named tropical system. Right now, the better description is a tropical moisture surge connected to the larger North American pattern. The Omega Block is helping pull moisture northward. The Bermuda High and surrounding flow are helping establish a pathway from the Caribbean and Gulf toward the southeastern United States. The Eastern Trough and Southern Branch energy help lift the moisture and turn it into rain. This is a moisture pipeline, not necessarily a storm. That distinction matters because early hurricane season is full of false alarms. The Caribbean and Gulf can produce large areas of thunderstorms before any organized circulation exists. These areas can bring heavy rain, gusty winds, rough seas, and flooding without becoming tropical cyclones. And sometimes, if conditions become more favorable, one of those messy areas can later organize. That is why the correct message is not nothing is happening, something is happening. The correct message is it is not organized into Arthur. This is where social media often gets the story wrong. It takes a real feature and gives it the wrong identity. The moisture surge is real. The rainfall threat is real. The tropical development window may become real. But Arthur is not real until the official criteria are met and the National Hurricane Center names the system. The difference is not just technical, it affects how people respond. If you tell people a storm is forming when it is not, some may panic. Others may become numb after repeated false alarms. Then, when a real storm threat appears later, they may ignore it because they have already heard the warning too many times. This is how hype creates danger. Accurate communication matters. People do not need exaggeration to prepare. They need clarity. And the clear message is this. There is no named storm yet. There is a moisture surge. It can produce heavy rain. It may help feed a more favorable environment later. It should be watched. But it should not be treated as a landfalling tropical storm before the atmosphere actually builds one. The Western Caribbean is one of the classic places to watch early in the Atlantic hurricane season. In June, the deep tropics farther east are often less favorable. Tropical waves coming off Africa usually become more important later in the season. Early on, development is more likely closer to the Western Caribbean, Gulf of Mexico, Bay of Campeche, or along old fronts and broad gyres. That is because these regions can combine warm water, deep moisture, weak steering, and leftover boundaries from mid-latitude systems. This year, the pattern is opening that kind of door. Warm waters in the Caribbean and Gulf provide background fuel. Deep moisture is already in place. The Omega Block is shaping the steering currents. The Madden-Julian oscillation may provide additional support if it moves into a phase favorable for convection over the Western Hemisphere. Those ingredients do not guarantee development, but they explain why forecasters are watching the period after the official start of hurricane season. This is the honest middle ground. Not hype, not dismissal. Attention. The Caribbean disturbance is not Arthur. but it is part of the environment that could eventually produce the first named storm if conditions line up. That if is important. Tropical development is a process, not a switch. A messy thunderstorm area must consolidate. Winds must begin wrapping around a center. Thunderstorms must persist instead of collapsing each night. Wind shear must not be too strong. Dry air must not disrupt the core. Land interaction must not tear the circulation apart. The system must have time over warm water. Many disturbances fail one of these tests. That is why most blobs on satellite never become named storms. They flare, they fade. They get pulled into fronts. They move over land. They get sheared apart. They remain broad and disorganized. Then the internet moves on to the next blob. But because this moisture surge is connected to a larger blocking pattern, it may linger long enough to keep attention focused on the region. That is what makes it different from a one-day thunderstorm cluster. The pattern may keep the Caribbean, Gulf, and Southeast loaded with moisture for several days. Repeated convection may continue. Broad areas of disturbed weather may remain visible. Model ensembles may occasionally show possible development. That creates the perfect environment for confusion. Every thunderstorm burst becomes Arthur. Every model run becomes a landfall threat. Every satellite image becomes evidence. But the official process is slower and more disciplined. Forecasters look for organization. They look for persistence. They look for whether the system is actually becoming tropical. Until then, the proper language is disturbance, moisture surge, broad low, or area to watch depending on what is present, not named storm. For viewers along the Gulf Coast, Florida, and Southeast, the practical message is straightforward. Do not ignore the pattern because there is no storm. But do not panic because someone online has named one. Prepare for heavy rain. Watch flood alerts. Begin normal hurricane season readiness. Follow official outlooks. If the National Hurricane Center begins monitoring an area, pay attention to the probabilities and forecast discussions. If nothing organizes, the main impact may remain rainfall. If something does organize, there will be time for the official forecast process to identify it. The Caribbean is the most emotionally charged part of this pattern because hurricane season carries memory. People remember past storms. They remember evacuations, flooding, power outages, storm surge, roof damage, and days of uncertainty. A single name can trigger anxiety. That is why accuracy matters. Arthur does not exist yet, but the pattern that could help create an early season system does exist. And that brings us to the chapter where the internet version and the real forecast version separate completely. Because there is a huge difference between saying a storm is forming now and saying the environment may become favorable later. One is hype. The other is meteorology. Chapter 10. No Arthur Yet. The internet storm versus the real forecast. The internet loves a storm before it exists. It loves the name. It loves the cone before there is a cone. It loves the red arrow before there is a center. It loves the satellite image before there is circulation. It loves the word forming because forming sounds urgent, even when the atmosphere has not crossed the line from disturbed weather into tropical cyclone development. That is why the Arthur rumors spread so easily. A dark thunderstorm mass over the western Caribbean looks convincing. A model run showing low pressure somewhere in the Gulf looks convincing. A thumbnail with a storm name stamped over the water looks convincing. But weather is not confirmed by how convincing an image looks. Weather is confirmed by structure, data, and official classification. And officially, Arthur has not formed. There is no named tropical storm unless the National Hurricane Center says there is one. There is no tropical depression unless the system meets the criteria. There is no official development area unless the NHC begins highlighting it in the tropical weather outlook. That does not mean the weather is quiet. It means the internet has jumped ahead of the atmosphere. This difference is critical. A moisture surge can be serious. A flood event can be serious. A tropical disturbance can be worth watching. But calling it a tropical storm too early changes the public's understanding of the threat. It shifts attention away from the real hazard, heavy rain and flooding, and toward a storm identity that may never exist. That can be dangerous in two ways. First, people may panic about wind and landfall when the immediate risk is water on roads, flash flooding, and repeated thunderstorms. Second, people may become exhausted by false alarms. If they hear Arthur is forming for several days and nothing forms, they may stop listening just when official forecasters begin highlighting a real risk. This is the storm hype cycle. A real atmospheric feature appears. Online creators exaggerate it. The public reacts. The feature fails to develop, trust drops. Then the next real threat has to fight through the noise. That is why a clear distinction matters. There is no Arthur now. There is a real moisture surge. There is a real flood risk. There may be an elevated tropical development window later. Those three statements can exist together. They are not contradictions. They are the responsible forecast. The reason early June is worth watching is because the background environment may become more supportive for tropical development. Warm waters in the Western Caribbean and Gulf can provide fuel. Deep moisture can reduce dry air disruption. The larger block can create weak steering and focus energy near the region. If the Madden-Julian oscillation supports rising motion over the Western Hemisphere, thunderstorm activity may become more persistent. But none of that automatically produces a storm. Ingredients are not a cake. They have to come together in the right order, in the right place, for long enough. The atmosphere can have warm water and moisture, but too much wind shear. It can have thunderstorms, but no surface center. It can have a broad low, but no concentrated core. It can have model support one day and lose it the next. That is why ensemble guidance matters. Ensembles show many possible futures. If a few members develop a system, that tells forecasters the possibility exists. If most members do not, that tells them uncertainty remains high. A minority signal is not a forecast of landfall. It is a reason to watch. This is where responsible language becomes important. The real statement is not, Arthur is coming. The real statement is, early season tropical development chances may become elevated in the Western Caribbean or Gulf region during the first part of June, but no storm has formed yet. That sentence is less clickable, but it is more honest. And in weather, honesty matters more than clicks. For people living along the Gulf Coast, Florida, and the Southeast, this means the correct posture is preparedness without panic. Preparedness means checking hurricane supplies because the season is beginning anyway. It means knowing where official forecasts come from. It means making sure flashlights, batteries, medications, documents, water, and plans are ready before any storm appears. It means knowing whether your home is in a flood zone. It means understanding evacuation routes if you live in a vulnerable coastal area. It means taking flood warnings seriously, even if there is no named storm. Panic means reacting to thumbnails. Panic means sharing unverified maps. Panic means assuming a model run is a forecast. Panic means believing a storm name before the official agency uses it. The atmosphere does not reward panic. It rewards attention. And right now, attention should be on the pattern. The omega block is the reason the tropical question exists at all. Without the larger setup, the moisture surge might be just another messy cluster of Caribbean thunderstorms. But with the block in place, moisture is being pulled north, steering currents are altered, rainfall corridors are established, and the Western Caribbean to Gulf region may remain active long enough for development chances to become non-trivial. That is why the pattern is more important than the name. Arthur may form later, or the first named storm may form somewhere else, or nothing may organize in the first window. But the rain, the heat, the cool air, the fire risk, and the moisture surge are already happening. The internet wants one villain. A named storm is easy to understand. It gives the story a face. It gives thumbnails a word. It gives viewers something to fear. But the real atmosphere is not always that simple. Sometimes the danger is a pattern without a name. Sometimes flooding comes from a moisture plume. Sometimes heat becomes the deadliest part of the map. Sometimes fire weather and flood warnings exist at the same time. Sometimes the first tropical threat of the season is not a storm yet, but a window. And that window requires careful watching. So if you see the name Arthur online before the National Hurricane Center uses it, remember this. A name is not a forecast. A thumbnail is not a warning. A model frame is not a landfall. A satellite blob is not a tropical storm. The official outlook is the authority. And until the atmosphere organizes a true system, the storm everyone is naming remains only a possibility. But the pattern behind it is not a possibility. It is already here. The block is already shaping the continent. The moisture is already moving. The flood corridor is already active. The plains heat is already building. The west is already under cold air aloft. The northeast is already on the cool side. And the Caribbean is already being watched, not because Arthur exists, but because the door may open. That is the real story, not the storm that has not formed. The pattern that has. Chapter 11. The real tropical window. There is a difference between a storm forming and a door opening. That difference is where the real forecast lives. Right now, the storm that people online are calling Arthur has not formed. There is no official name system, no tropical depression, no confirmed center spinning over the Western Caribbean, no warning cone, and no landfall forecast. But that does not mean the atmosphere is closed for business. It means the atmosphere is preparing a window. And windows are important. A tropical development window is not a guarantee. It is a period when the background ingredients become more favorable than they were before. It means the atmosphere may become more supportive of organization if a disturbance can survive long enough, stay over warm water long enough, and pull itself together before wind shear, dry air, or land interaction disrupts it. Early season tropical systems often form in messy ways. They do not always begin as clean, beautiful spirals moving across the Atlantic. In June, the deep tropical Atlantic is often still not the main stage. The more common areas to watch are closer to land, the Western Caribbean, the Gulf of Mexico, the Bay of Campeche, the waters near Florida, old frontal boundaries, broad low-pressure gyres, and moisture-rich zones where thunderstorms repeat day after day. That is why this setup matters. The Western Caribbean and Gulf region are not quiet. The atmosphere has already been pulling tropical moisture northward into the Gulf Coast and southeast. Thunderstorms are already flaring. Rain corridors are already active. The moisture is already deep. The waters are already warm enough to support development if the right structure forms. The question is whether the atmosphere can organize. That is always the question. Warm water alone does not create a storm. If it did, the Gulf and Caribbean would spin up systems constantly during hurricane season. A tropical cyclone needs organization. It needs a low-level center. It needs thunderstorms to persist near that center. It needs the winds at different levels of the atmosphere to cooperate rather than tear the system apart. It needs enough time over water. It needs the surrounding pressure pattern to allow inflow to wrap inward instead of spreading out loosely over a giant area. In this case, several ingredients are worth watching. The first is ocean warmth. The Caribbean and Gulf are warm enough to provide fuel. Early season systems do not need the entire Atlantic to be at peak September heat. They need a local zone of warm water and enough atmospheric support above it. Warm water helps thunderstorms grow and helps maintain the heat engine that tropical systems require. The second ingredient is moisture. Dry air is one of the enemies of tropical development. A dry atmosphere can cause thunderstorms to collapse before they can organize. But this pattern has already loaded the region with tropical moisture. That does not guarantee a storm, but it reduces one common obstacle. The third ingredient is lift. The larger omega block and its surrounding troughs help create areas where air is encouraged to rise. Rising air supports thunderstorm development. If that lift overlaps with warm water and a developing low-pressure area, the environment becomes more interesting. The fourth ingredient is wind shear. This may be the deciding factor. Wind shear is the change in wind speed or direction with height. If winds near the surface are moving one way and winds higher up are racing another way, a developing tropical system can get tilted and ripped apart. It may produce thunderstorms, but those thunderstorms get displaced from the center. Organization fails. If shear relaxes during the right window, development chances rise. The fifth ingredient is time. A disturbance needs time over water to consolidate. If it is pulled too quickly north into land, it may only produce rain. If it sits too close to Central America or the Yucatan, land interaction may disrupt it. If it remains broad and messy, it may never tighten into a classified system. That is why the real forecast is uncertain. There is a pathway to development. There is also a pathway to nothing more than heavy rain. There is a pathway where a weak low forms and never becomes named. There is a pathway where a depression forms but struggles. There is a pathway where a named storm develops later than social media expects. And there is a pathway where the first named storm of the season forms somewhere else entirely. This is why ensembles matter. A single model run can show one dramatic solution, but that does not mean the atmosphere will follow it. Ensembles run many versions of the future with slightly different starting conditions. If only a small number of members show tropical development, the signal is real but uncertain. If more members begin showing development in the same region and time period, confidence increases. If the signal disappears, the threat decreases. The honest position is not to ignore the signal. The honest position is to size it correctly. The development chance is not high enough to declare a storm. It is not low enough to dismiss the region. This is the middle ground that responsible weather communication must hold. And it is especially important because the official start of Atlantic hurricane season changes public attention. Once June begins, every Caribbean thunderstorm cluster gets more scrutiny. Every model low gets shared. Every hint of rotation becomes a headline. People are already primed to look for the first name, but the atmosphere does not care about the calendar line. June 1st does not magically create storms. It simply marks the beginning of the official season, because climatology says tropical activity becomes more likely from that point onward. Some years start before June. Some start later. Some early systems are weak and rain-heavy. Others become more organized. The key is not the date alone. The key is the environment. This environment is interesting because the Omega Block has helped build a moisture highway from the tropics toward the United States. It has changed steering patterns. It has supported repeated rainfall. It has allowed the Western Caribbean and Gulf to remain active on satellite. It has created a situation where early tropical development is at least worth monitoring. But there is a major difference between monitoring and warning. Monitoring means stay informed. Warning means a threat is identified and official products are issued. Right now, the proper mindset for coastal residents is not fear. It is preparation. Hurricane season begins whether Arthur forms or not. Supplies should be checked. Plans should be reviewed. Flood risks should be understood. People should know their official sources. Families should know what they would do if a tropical system eventually threatened their area. But no one should evacuate because of a model image. No one should assume a landfall because of a thumbnail. No one should treat an unofficial storm name as fact. The right phrase is preparedness without panic. That phrase matters because it keeps people balanced. Too little attention is dangerous. Too much hype is also dangerous. The middle is where people make good decisions. If development begins, the official signs will become clearer. The National Hurricane Center may highlight an area. Development percentages may appear. Reconnaissance may eventually investigate if needed. Satellite organization may improve. Pressure may fall. A center may form. Forecast tracks may begin. Until then, the main impact remains rain. Heavy rain can happen whether tropical development occurs or not. Flash flooding can happen without a named storm. Saturated ground can create hazards before any cone exists. That is why the Gulf Coast, Florida, and Southeast must keep watching rainfall first. The tropical window matters because it is the next possible step in the pattern, not because it has already happened. The atmosphere has opened the door slightly. Now we wait to see whether anything walks through. And while everyone watches that southern door, the rest of America is already feeling the block in full force. Heat in one region, cool air in another, cold aloft in the west, flooding rain along the Gulf, drought relief in the southeast, tropical uncertainty to the south. The storm may be uncertain, but the split across the continent is not. Chapter 12. America split into different seasons. There are moments when the weather map stops looking like a forecast and starts looking like a broken calendar. This is one of those moments. Look across North America during this pattern and you do not see one season. You see several seasons layered over the same country at the same time. In the northern plains, the air feels like summer has arrived too early. Temperatures surge toward levels more typical of the hottest part of the season. The sun bakes dry ground. Afternoon humidity drops. Wind turns heat into fire danger. The landscape feels exposed, brittle, and ready for one spark to become a problem. In the northeast, the story is different. The air cools behind the front. Clouds return. Showers move through. The calendar says early June, but the sky feels like spring has refused to leave. People who expected warm evenings and summer plans find themselves under a trough that delays the season. In California, the upper atmosphere tells a third story. Cold air aloft spins over the west. Coastal areas stay cool. Valleys run below normal. Mountain showers and even late-season snow at high elevations become possible. The surface may not look like January everywhere, but the steering levels above the state carry a winter-like signature that is deeply out of place for late May and early June. Along the Gulf Coast, the story is water. Thunderstorms repeat. Moisture pools. Boundaries stall. Roads flood in some areas, while other counties wait for the next round. The rain is not simply falling from a single storm. It is being manufactured by a corridor of moisture and instability. Across the southeast, the story becomes even more complicated. The same rain that creates flood risk may also begin to crack a drought that has lasted for months. Farmers need the water. Reservoirs need recharge. Soil needs moisture. But if the rain falls too hard, it runs off. If storms train, they flood. The relief arrives with warnings attached. And to the south, over the western Caribbean and Gulf, the story is uncertainty. There is no named storm yet, but the moisture is real. The disturbance is real. The environment may become more favorable. The first tropical window of the season is opening while the internet tries to name a system before the atmosphere does. This is the national split. One country, different seasons, same pattern. That is the power of the Omega block. It does not create the same weather everywhere. It creates organized contrast. And organized contrast can be more revealing than any single extreme. If the entire country were hot, the story would be simple. A widespread heat wave. If the entire country were cool, the story would be simple. A late-season chill. If the entire South were wet, the story would be a rain event. If the Caribbean alone were active, the story would be tropical. But this setup is not simple. It is a continental pattern with regional consequences. The ridge in the middle pushes heat northward and holds it there. The western low keeps California and the Great Basin cooler and unsettled. The eastern trough sends cooler air into the northeast. The Bermuda High and southern flow pull tropical moisture toward the Gulf Coast and southeast. The same blocked steering currents help create the environment where the Caribbean must be watched. Each region sees only its face of the pattern. A person in North Dakota may wonder why it is so hot so early. A person in Boston may wonder why early June feels so cool. A person in Los Angeles may wonder why the atmosphere feels stuck in a cloudy, breezy, out-of-season mood. A person in Houston may wonder why storms keep finding the same corridor. A person in Georgia may wonder whether this rain will finally help the drought. A person in Florida may wonder whether the Caribbean moisture is the beginning of something tropical. All of them are asking local questions. The answer is continental. The atmosphere has slowed down. The jet stream has bent into a large wave. The ridge and troughs are locked into position. The result is not chaos. It is a machine, and machines have parts. The plains heat is one part. The northeast cool down is another. The west coast cold pocket is another. The Gulf rain corridor is another. The southeast drought relief is another. The tropical window is another. Different outputs from the same engine. This is why the phrase weird weather does not go far enough. Weird implies random. This is not random. It is unusual, but it is organized. It is strange, but it has a structure. It looks confusing at the surface because each region receives a different result, but the upper air pattern ties the results together. That is also why the next 2 weeks may feel different depending on where people live. In some places, the atmosphere will feel ahead of schedule. The heat will feel like summer arrived too early. In some places, it will feel behind schedule. Cool air and clouds will make June feel delayed. In some places, the atmosphere will feel overloaded. Humidity, storms, and rain will dominate. In some places, it will feel unstable and misleading. Satellite images may look tropical even before a storm exists. This is how a block can distort time. It does not literally change the calendar, but it changes the weather people associate with the calendar. The plains get July. The Northeast gets May. California gets a taste of winter aloft. The Gulf Coast gets a tropical rain season preview. The Southeast gets drought relief and flood concern at the same time. The Caribbean gets watched before anything is named. The country enters June through multiple doors at once. And that matters because people prepare based on expectations. If someone expects ordinary early June weather, they may underestimate heat. If they expect a typical thunderstorm day, they may underestimate flood risk. If they expect summer beach weather, they may ignore rip current danger. If they expect drought to continue, they may not be ready for sudden heavy rain. If they expect every Caribbean thunderstorm mass to become a hurricane, they may panic too early. The block disrupts expectations. That is why communication matters. People need to understand not only what is happening, but why it is happening. They need to know that the lack of a named storm does not mean the lack of danger. They need to know that cool weather in one region does not disprove heat danger in another. They need to know that drought relief can come with flash flooding. They need to know that a single pattern can produce opposite hazards at the same time. This is the central lesson of the entire event. Weather is connected. The atmosphere does not respect state lines. It does not message clipped, view entire message. It does not divide itself into local headlines. It moves as a fluid system, and when that fluid system becomes blocked, the consequences appear everywhere in different forms. The omega block is the hidden shape behind the visible chaos. It is why one part of the map burns while another floods. It is why one region sweats while another reaches for a jacket. It is why a storm that does not exist can still become the focus of attention, because the pattern around it is real enough to make people nervous. The country is not experiencing one kind of extreme. It is experiencing a split. And the next question is timing. How long does the split last? When does the heat peak? When does the rain corridor become most active? When does the tropical window become most important? When does the block begin to weaken? To answer that, we need to walk through the first 10 days of June, not as a perfect forecast, because the details will change, but as a pattern timeline, a rough map of how this atmospheric machine may evolve day by day as the country moves deeper into a month that may not feel like June at all. Chapter 13. The first 10 days of June. The first 10 days of June do not begin with a clean reset. They begin with a pattern already in motion. The atmosphere does not flip a switch at midnight when hurricane season officially begins. The ridge does not vanish. The trough does not lift out instantly. The moisture surge does not disappear. The cold air aloft over the west does not suddenly remember the calendar. The block carries its late May setup directly into the opening days of June. That is why the timeline matters. The first phase is the transition out of late May and into June 1st. During this period, the pattern finishes locking in. The plains heat continues building. The western upper low remains influential. The eastern trough keeps cooler air and unsettled weather over the northeast and mid-Atlantic. The Gulf Coast and southeast remain under the growing influence of tropical moisture. The Caribbean continues to show disturbed weather, but without an official name system unless organization actually develops. This is the phase where people begin noticing the split. In the plains, temperatures rise. In the east, the air feels cooler behind the front. In the south, rain chances increase. In the west, the atmosphere remains unusually cool aloft. The second phase comes around June 1st through June 3rd. This is when the plains heat may become one of the dominant national stories. The ridge reaches a stronger point. Temperatures across parts of eastern Montana, western North Dakota, South Dakota, Minnesota, and nearby areas can push well above normal. Some locations may challenge daily records. Heat risk increases, especially because it is early in the season. Fire weather remains a major concern where the heat overlaps with low humidity and gusty winds. Dry vegetation, afternoon wind, and strong heating create a dangerous combination. This is the period when one careless spark can matter. At the same time, the Northeast remains on the cooler side of the pattern. Daytime highs may stay below what people expect for early June. Showers remain possible. Disturbances may rotate through the trough. The mood is unsettled and delayed. In the south, the rain corridor continues. Florida enters a wetter pattern. The Gulf Coast sees repeated thunderstorm chances. Some places receive beneficial rain. Others face localized flooding. The key is repetition. Each round changes the ground for the next round. This is also when hurricane season officially begins, which means public attention shifts sharply toward the tropics. But again, the calendar does not create a storm. If no system has organized, then no storm exists. The focus remains on rainfall and monitoring. The third phase is roughly June 3rd through June 6th. This may be the most important tropical watch period within the early window. By this point, the moisture surge has had time to persist. The Western Caribbean, Gulf, or nearby regions may remain active. If wind shear relaxes, if pressure begins falling, and if thunderstorms persist around a developing center, this is the kind of period when forecasters would begin paying closer attention. But the uncertainty remains high. This phase could produce nothing tropical at all. It could produce only a broad low and more rain. It could produce a weak depression. It could produce the first named storm if the ingredients align. The key is not to assume the outcome before the data supports it. During the same period, the Gulf Coast and Southeast may still face flooding concerns. Even if daily rainfall amounts begin to vary, saturated ground can make later storms more efficient at producing runoff. Flash flood risk can continue even after the biggest rain day has passed. The plains heat may begin to shift or slowly ease in some locations depending on how the ridge evolves, but if the block remains strong, above normal heat can persist. The Northeast may continue receiving disturbances in the northwest flow, keeping temperatures cooler and showers in the forecast. The West may begin warming if the upper low weakens or drifts away, but the speed of that transition matters. If the western low holds longer, the block remains more stable. If it exits faster, the overall pattern may begin loosening. The fourth phase is roughly June 7th through June 10th. This is when the block may start showing signs of weakening or reconfiguration. The word weakening does not mean everything suddenly returns to normal. Large patterns often fade unevenly. One anchor loosens while another remains. The western low may retreat. The central ridge may relax but not disappear. The eastern trough may still be reinforced by smaller disturbances. The Bermuda High may continue feeding moisture into the southeast. This phase can be tricky because people may assume the danger is ending just as the pattern becomes more subtle. But impacts can lag behind the atmosphere. If the ground is saturated, flooding remains easier. If the plains have baked for several days, fire fuels remain stressed. If heat has accumulated, vulnerable people may still be affected. If a tropical system formed earlier, it may now be moving under clearer steering currents. If no tropical system formed, the region may still be wet and unsettled. This is why the end of a block is not always clean. Weather patterns have memory. The land remembers heat through dry vegetation. Rivers remember rain through elevated flows. Soil remembers drought through poor absorption. The ocean remembers warmth through tropical fuel. Human systems remember stress through power demand, emergency response, and public fatigue. So the first 10 days of June should be understood as a sequence, not a single event. Late May into June 1st, the pattern locks in. June 1st to June 3rd, plains heat peaks, fire danger rises, southern rain expands. June 3rd to June 6th, tropical monitoring becomes more important while flood risk continues. June 7th to June 10th, the block may begin to loosen, but consequences remain. There is also a fifth phase beyond June 10th. By then, the atmosphere may begin moving toward a more conventional summer pattern. The jet stream may flatten somewhat. The ridge may shift, the troughs may relax, but conventional summer does not mean quiet. A more normal summer pattern can still bring heat, storms, tropical moisture, and flooding. The difference is that the extreme split may become less sharp. The plains may not remain as dramatically hotter than the east. The west may return closer to seasonal norms. The northeast may gradually warm. The Gulf Coast may transition from a blocked rain corridor into a more typical humid thunderstorm regime. The tropics may either have produced a system or moved into the next watch period. But until that transition is clear, the Omega block remains the lead story. Forecast details will change. Exact rainfall totals will shift. Model runs will move possible lows around. Some cities will get more heat than expected. Some will get less. Some counties will flood while nearby counties miss the worst rain. Some tropical signals will appear and disappear. That is normal. The structure matters more than any single run. The structure says the first 10 days of June are not ordinary. They are being shaped by a blocked atmosphere. And for viewers, the most useful thing is not memorizing every model frame. It is knowing what signals to watch, because the atmosphere will give clues before the headlines catch up. Those clues are visible in the official outlooks, the moisture values, the red flag warnings, the rainfall maps, the satellite organization, and the temperature gradient across the country. The next chapter is about those signals, what to watch, what matters, and what should be ignored. Chapter 14, Signals to Watch. When a pattern becomes this large, the hardest part is knowing where to look. There are too many maps, too many model runs, too many social media posts, too many warnings, too many people claiming certainty before the atmosphere has provided it. So the most useful thing a viewer can have is a watch list. Not a panic list, a watch list. The first signal to watch is the National Hurricane Center Outlook. This is the authority for tropical development in the Atlantic Basin. If a real area of concern begins to organize, the outlook will say so. It will highlight the area, describe the disturbance, and assign development probabilities over short and longer time windows. Until that happens, unofficial storm names should be treated with caution. The phrase to watch for is something like, "An area is being monitored for possible tropical or subtropical development." Once that language appears, the situation has changed. Before it appears, the main story may still be moisture, rain, and disturbed weather rather than a classified tropical threat. The second signal is satellite organization. Not just clouds, organization. A big thunderstorm blob does not equal a storm. Look for persistence. Do thunderstorms keep firing near the same center? Is there rotation at low levels? Are storms wrapping inward? Is the system becoming more compact, or is it stretched out and messy? Does convection survive overnight, or does it collapse and restart somewhere else the next day? Tropical development is about structure, not just intensity. The third signal is wind shear. If shear remains strong, tropical organization becomes difficult. The thunderstorms may get pushed away from the developing center. The system may stay lopsided and weak. If shear relaxes during the watch window, development chances can rise quickly. This is one reason forecasts can change. A disturbance that looks disorganized under shear can become more interesting if upper winds improve. The fourth signal is pressure. A developing tropical system usually shows falling pressure and a more defined low. If pressure falls steadily and winds begin wrapping around a center, forecasters pay closer attention. If pressure stays broad and disorganized, the system may remain only a moisture surge. The fifth signal is rainfall repetition. For most people in the Gulf Coast and Southeast, the biggest near-term danger may be flooding, not tropical wind. Watch for repeated storms over the same areas. Watch for flood watches and flash flood warnings. Watch for saturated ground. A place that handled the first storm may not handle the third. This is especially important at night. Flash flooding becomes more dangerous when people cannot see water covering roads. Many flood deaths happen in vehicles. The rule is simple: never drive through flooded roads. The sixth signal is precipitable water. This is the moisture measurement we began with. When values are extremely high for the date, storms can produce heavy rainfall efficiently. The atmosphere becomes loaded. If a trigger arrives, rain rates can become intense. High precipitable water does not guarantee flooding by itself, but it tells us the atmosphere has the fuel. The seventh signal is the red flag warning footprint. For the Plains, Great Basin, and dry western areas, this may be more important than rainfall maps. Red flag warnings show where heat, wind, low humidity, and dry fuels combine to create dangerous fire conditions. If the footprint expands or persists day after day, the fire risk remains serious. Do not think of fire weather as only a forest problem. Grassland fires can move extremely fast. Agricultural areas can burn. Roadside fires can spread. Under wind and low humidity, small mistakes become large incidents. The eighth signal is the temperature gradient. Compare the plains to the east. If cities at similar latitudes remain separated by large temperature differences, the block is still strong. A sharp gradient means the ridge and trough are still holding their positions. If the gradient begins to relax, the pattern may be loosening. This is one of the easiest ways to see the block without looking at advanced maps. Where is it much hotter than normal? Where is it cooler than normal? How sharp is the contrast? The ninth signal is the western upper low. This is the California and Great Basin anchor. If it remains deep and slow-moving, the omega structure has support. If it weakens and moves away faster, the block may begin to transition. What happens in the west affects the whole pattern, even for people thousands of miles away. The 10th signal is the Bermuda High. If it remains positioned to pump moisture northward, the southeast and Gulf coasts stay wet. If the high shifts, the moisture pipeline can change. The position of that high also matters for any tropical system that might eventually form, because steering around high pressure can help determine where a system moves. The 11th signal is soil response in the southeast. Rainfall totals alone do not tell the full drought story. Watch whether rain is soaking in or running off. Watch stream flow. Watch reservoir response over time. Watch drought monitor changes in the following weeks. A wet forecast map does not instantly erase months of deficit. The 12th signal is public messaging. This may sound unusual, but it matters. When official sources become more specific, pay attention. When social media becomes more dramatic without official support, be cautious. The gap between hype and reality can become large during early hurricane season. A responsible viewer should ask 3 questions every time they see a dramatic post. Who is the source? Is the National Hurricane Center saying the same thing? Is this a forecast or just one model run? Those 3 questions can prevent a lot of confusion. The 13th signal is model consistency. One model run showing a storm does not mean a storm is likely. Multiple runs showing a similar signal over time matter more. Multiple ensemble members showing development matter more. Agreement between different model systems matters more. Trend matters more than drama. The 14th signal is whether the block actually weakens. This is the big one. If the omega block holds longer than expected, impacts can extend. Heat can persist. Rain can repeat, flood risk can grow, tropical moisture can remain in play. If it weakens sooner, impacts may reduce faster. The block is the master signal. Everything else is downstream. For viewers, this means the best approach is calm attention. Do not chase every model frame. Do not believe every storm name. Do not ignore official flood warnings because there is no hurricane. Do not dismiss heat because it is early. Do not assume rain ends drought instantly. Do not assume cool weather means no hazards. Watch the pattern. Watch the official sources. Watch what repeats. Because repetition is the key. One hot day is a forecast. Repeated hot days are a heat event. One storm is weather. Repeated storms are a flood threat. One satellite burst is convection. Persistent organization is tropical development. One cool morning is a surprise. A week of cool, unsettled weather is the trough holding. One dry afternoon is uncomfortable. Several dry, windy afternoons are fire weather. The atmosphere is telling the story through repetition, and the omega block is the reason the repetition exists. So as the first 10 days of June unfold, the most important question is not whether every model run is right. It will not be. The most important question is whether the main signals continue pointing in the same direction. Does the ridge hold? Does the trough remain? Does the moisture pipeline continue? Does the western low retreat? Does the tropical disturbance organize? Do flood warnings expand? Do red flag warnings persist? Do official outlooks change? Those are the questions that matter. And if you follow those signals, the next phase of this pattern will make much more sense than the headlines. Because the headlines will keep separating the story. Heat here, rain there, cool air somewhere else, possible storm in the Caribbean. But the atmosphere is not telling separate stories. It is repeating one message through different regions. The block is still in control, and until that changes, every signal on the map should be read through that shape. Chapter 15. The bigger climate context without the hype. Every major weather pattern lives in two worlds. The first world is the immediate atmosphere. That is the world of ridges, troughs, jet streams, cold fronts, moisture surges, thunderstorms, wind shear, and tropical disturbances. It is the world forecasters watch hour by hour and day by day. It is the world that tells us where the rain falls tomorrow, where the heat peaks on Tuesday, where the fire danger rises in the afternoon, and where a tropical low may try to organize later in the week. The second world is the background environment. That is the world of warm oceans, dry soils, long-term drought, changing seasonal baselines, warmer nights, higher moisture capacity, stressed reservoirs, and landscapes that may respond differently to the same weather pattern than they did decades ago. The omega block belongs to the first world, but the impacts of the omega block are shaped by the second. That distinction matters because this is where people often lose the truth in two opposite directions. One side wants to say every strange weather event is proof of one big cause. The other side wants to say no single weather event means anything at all. The honest answer is more careful. A single omega block is weather, but the environment it forms inside can make its consequences worse, stranger, wetter, hotter, or more damaging. That is where climate context becomes important. Start with moisture. A warmer atmosphere can hold more water vapor. That does not mean every storm will produce flooding. It does not mean rain falls everywhere equally. But when a moisture-rich pattern sets up, the ceiling for heavy rainfall can be higher. Storms can become more efficient rain producers. Rainfall rates can become more intense. When thunderstorms train over the same location, the totals can rise quickly. That matters for the Gulf Coast and Southeast. The rain corridor in this pattern is not just a line of showers. It is a moisture-loaded environment interacting with boundaries and repeated thunderstorm development. When the atmosphere has more water available, the same kind of setup can produce heavier downpours than a drier background environment would allow. Then look at heat. The plains heat dome is a weather feature. It is being produced by the central ridge, sinking air, compression, and dryness. But the heat is happening in a world where warm season baselines have shifted in many areas. Early season heat can become more intense, more frequent, or more dangerous when the background climate is warmer. Again, this does not mean the ridge is caused by one simple factor. It means the ridge is operating on a warmer playing field. That difference matters for people. A high temperature that once would have been near the edge of the record may become easier to reach. Nights may not cool as effectively. Heat stress may build faster. Vulnerable populations may face more risk earlier in the season. Now look at drought. Drought is not only the absence of rain, it is the accumulation of deficits over time. It affects soil, rivers, reservoirs, crops, vegetation, groundwater, and ecosystems. When a blocking pattern brings heat and dryness over an already dry region, fire danger can intensify quickly. When it brings heavy rain over drought-stressed ground, the first rain may run off instead of soaking in. That is why drought makes both fire and flood behavior more complicated. Dry ground can burn. Dry ground can also flood. It depends on how the rain arrives. A slow soaking rain is one thing. A tropical downpour is another. The southeast may need water badly, But if the water arrives too fast, it can create flash flooding before deeper recovery begins. Then look at the oceans. Early season tropical development depends heavily on local conditions. Warm water does not guarantee a storm, but it provides fuel. If the Western Caribbean and Gulf are warmer than average, then disturbances that might have struggled in a cooler background may have a better chance if wind shear and organization cooperate. This is one reason early season tropical windows deserve attention. Not panic. Attention. Warm water lowers one barrier. It does not remove all barriers. A disturbance still needs structure. It still needs time. It still needs favorable winds aloft. But if those pieces line up, a warm ocean can make development more likely or help a system produce heavier rainfall. This is the balanced climate message. The pattern is weather. The background can load the dice. And when a blocked pattern forms over a loaded background, the impacts can become more serious than the map alone suggests. Blocking itself is also part of a larger scientific conversation. High-amplitude jet stream patterns, long-duration ridges, stuck troughs, and persistent weather regimes have always existed. The atmosphere has always produced blocks. But there is ongoing scientific discussion about how changes in the Arctic, ocean temperatures, and large-scale circulation may influence the frequency, persistence, or behavior of certain blocking patterns. We do not need to overstate that to understand this event. The practical point is simple. When the atmosphere slows down, whatever is underneath it gets amplified. If heat is underneath, heat builds. If drought is underneath, drought deepens. If moisture is underneath, flood risk grows. If warm water is underneath, tropical potential may increase. If dry fuels are underneath, fire danger rises. A block is like a magnifying glass. It does not create every ingredient from nothing. It focuses them. This is why the first 2 weeks of June matter beyond the daily forecast. They are showing how different vulnerabilities can exist side by side across the same country. The plains are vulnerable to heat and fire. The southeast is vulnerable to drought and flooding at the same time. The Gulf Coast is vulnerable to heavy rain without a named storm. The Northeast is vulnerable to stalled cool and unsettled conditions that disrupt expectations. The West is vulnerable to strange late-season upper-level cold that may look dramatic but does not solve deeper water problems. The tropics are vulnerable to misinformation before they are vulnerable to a storm. All of these vulnerabilities sit under the same pattern. That is the larger lesson. Extreme weather is not only about the sky, it is about the sky meeting the surface. A heat dome over green, wet land is different from a heat dome over dry fuels. A thunderstorm over normal soil is different from a thunderstorm over burned, baked, or saturated ground. A tropical moisture surge over healthy reservoirs is different from one over drought-stressed watersheds. A possible tropical disturbance over average water is different from one over unusually warm water. The atmosphere provides the trigger. The background decides how hard the trigger hits. This is why responsible weather storytelling should avoid both exaggeration and dismissal. The situation does not need conspiracy. It does not need fake certainty. It does not need dramatic storm names before storms exist. The real pattern is already powerful enough. The heat is real. The flood risk is real. The drought relief is real. The fire danger is real. The tropical window is real. The uncertainty is also real. That is the mature way to tell the story. The atmosphere has built a block. The land and ocean beneath it are not neutral. They are carrying memory from previous months and previous seasons. The first 2 weeks of June are where those memories meet the present pattern. And when weather meets memory, impacts are born. That is the bigger context. Not hype, not panic, not denial. A blocked atmosphere, warm water, dry land, deep moisture, vulnerable regions, and a public trying to understand why the country suddenly feels like several different seasons at once. But maps and measurements are only one part of the story. The next part is human, because every atmospheric pattern eventually reaches the ground. And when it does, it becomes someone's workday, someone's farm, someone's road, someone's home, someone's fear, and someone's decision. Chapter 16. The human side of the block. A weather pattern this large can look almost beautiful from above. On an upper air map, the omega shape has symmetry. The ridge rises. The troughs dig. The lines bend around the continent in a way that seems organized, almost artistic. Satellite images show moisture streaming north, clouds wrapping around lows, dry zones clearing out beneath high pressure. From space, it looks like motion. From the ground, it becomes life. In western North Dakota, a rancher steps outside before noon and already knows the afternoon will be difficult. The wind has started early. The grass is dry. The heat is climbing. The sky is clear in that dangerous way, without clouds to slow the sun or rain to soften the ground. The forecast says heat. The red flag warning says fire. But the rancher does not experience those as terms. He experiences them as decisions. Can machinery run safely today? Is there enough water for livestock? Should work be moved earlier? What happens if a spark jumps from equipment into grass that is ready to burn? The omega block is not an abstract pattern there. It is a pressure on every outdoor decision. In South Dakota or Minnesota, a road crew feels the early season heat rising off pavement. Workers who expected warm weather are suddenly facing something closer to midsummer. The body is not adjusted yet. Sweat comes faster. Fatigue comes earlier. Breaks matter more. Water matters more. Shade matters more. A heat dome is not just a number on a screen. It is the difference between a normal workday and a dangerous one. Farther east, in Pennsylvania or New York, someone planning an early summer weekend looks at the forecast and feels confused. The calendar says June. The closet says short sleeves. The sky says something else. Clouds move in. The wind feels cool. Showers return. A beach plan starts to look questionable. A graduation event may need umbrellas. A baseball game may be delayed. This is not an emergency for most people, but it is still the pattern reaching into daily life. The Northeast is not suffering the heat side of the block. It is feeling the delayed summer side. The effect is softer, but it is still real. People plan around seasons, and the atmosphere has interrupted the expected rhythm. On the California coast, someone wakes up to another gray, cool morning. The air feels more like the Pacific Northwest than Southern California. Farther inland, mountain communities watch for showers. At higher elevations, late-season snow appears as a strange reminder that the upper atmosphere is not following the calendar. For tourists, it may be an inconvenience. For water managers, it is another small detail in a much larger drought story. For forecasters, it is a sign that the western anchor of the block is still present. In Texas, the human side looks different. It looks like a driver approaching a flooded road and making a decision that could become life or death. The water may not look deep. The crossing may be familiar. The rain may have already stopped overhead. But water does not need to be deep to be powerful, especially when it is moving. Flash flooding is one of the most deceptive hazards because the danger often appears ordinary until it is too late. A flood warning is not background noise. It is a message that the atmosphere has already delivered more water than the ground and drainage systems can safely handle. In Houston, someone watches water collect near an underpass. In the hill country, someone hears rain upstream and knows creeks can rise fast. In Louisiana or Mississippi, families hear thunder again after already receiving rain the day before. The Gulf Coast rain machine does not become personal when the first drop falls. It becomes personal when the same areas are asked to absorb too much water too quickly. In Georgia or Alabama, a farmer may welcome the rain with relief and worry at the same time. The soil needs it. The crops need it. The reservoirs need it. The entire region needs the pattern to break the dry spell. But if the rain comes in hard bursts, it can wash out fields, delay work, or run off before it helps deeper soil moisture. Drought relief is rarely as simple as rain falling from the sky. The land has to receive it. The watersheds have to process it. Reservoirs have to respond. So the farmer watches not only whether rain comes, but how it comes. That is the human side of drought relief with a flood warning attached. In Florida, the human side may look like people cleaning drains, checking weather apps, and watching the sky darken in the afternoon. South Florida knows thunderstorms. It knows tropical rain, but high moisture days still matter. Rainfall rates can overwhelm streets quickly. The difference between normal rainy season weather and flood-producing downpours can be small but important. And then there is the Caribbean question. The human side there is anxiety. People along the Gulf Coast and Florida do not need much imagination to fear tropical systems. They have memory. They remember past storms, evacuations, long gas lines, empty shelves, flooded homes, power outages, insurance claims, and nights spent listening to wind. So when the first viral posts of the season start shouting a storm name, the reaction is emotional. Is it coming here? Do we need to prepare? Is this real? Who do we trust? That last question may be the most important, because modern weather does not only happen in the atmosphere, it happens online. The public now experiences storms through thumbnails, model screenshots, live streams, social posts, and headlines before official forecasts have even identified a system. This creates a second storm, a storm of information, some of it useful, some of it premature, some of it exaggerated, some of it designed for fear. And in early hurricane season, that information storm can form before the real one. That is why the message has to remain steady. No Arthur yet. Real moisture, real flood risk. Possible tropical window. Official sources matter. Preparedness without panic. This chapter of the story is human because every region is being asked to respond to uncertainty in a different way. The plains must respect heat before it becomes deadly. The dry regions must avoid sparks before fire starts. The Northeast must adjust expectations. The West must understand that dramatic late-season cold aloft does not erase drought. The Gulf Coast must treat flooding seriously without waiting for a storm name. The Southeast must welcome rain while respecting runoff and flash flooding. Coastal residents must prepare for hurricane season without being manipulated by hype. The same block asks different questions of different people. Are you ready for heat? Are you ready for rain? Are you ready for fire danger? Are you ready for cool, unsettled weather? Are you ready for hurricane season? Are you ready to wait for official information before reacting? This is what a continental pattern does. It enters homes, farms, roads, beaches, emergency offices, power grids, reservoirs, and phones. It changes plans. It creates warnings. It tests communication. It forces people to make choices before the largest impacts are fully visible. And that is why the final part of this script cannot only be about maps. It has to be about what people should do. Not panic. Not ignore. Prepare. Because the atmosphere has created a pattern that deserves attention, and attention is only useful when it becomes action. Chapter 17. Preparedness without panic. The right response to this pattern is not fear. It is readiness. Fear burns energy before anything happens. Fear makes people chase rumors, share bad information, and react to the loudest voice in the room. Readiness is different. Readiness is calm. Readiness says the pattern is unusual, the risks are real, the details are uncertain, and the best thing to do is prepare before the moment becomes urgent. That is the posture people need for the first days of June. Preparedness without panic. For the plains and upper Midwest, preparedness starts with heat. If temperatures rise well above normal early in the season, treat the heat seriously even if the calendar makes it feel too soon. Avoid the most intense afternoon activity if possible. Move outdoor work earlier. Take breaks. Drink water before thirst becomes urgent. Check on older relatives, neighbors, and anyone without reliable cooling. Heat illness can sneak up. It does not always begin dramatically. It can start as fatigue, dizziness, headache, weakness, confusion, or nausea. By the time someone realizes they are in trouble, they may already need help. Early season heat is especially risky because people are not yet acclimated. For the same region, fire preparedness matters too. If red flag warnings are in effect, avoid outdoor burning. Be careful with equipment. Watch anything that can create sparks. Secure trailer chains. Do not park hot vehicles over dry grass. Follow local fire restrictions. In dry, windy conditions, fire can spread faster than people expect, especially through grassland. A fire does not need a forest to become dangerous. It needs fuel, wind, low humidity, and ignition. This pattern can provide the first three. People must prevent the fourth. For the Northeast and Mid-Atlantic, the message is different. The danger is not extreme cold. It is unsettled weather, thunderstorms near frontal boundaries, cooler than expected conditions, and coastal hazards that may be underestimated. If storms are forecast along a front, pay attention to severe thunderstorm warnings. Damaging wind gusts can happen even in a pattern that later turns cool and pleasant. If you are near the coast, respect rip current statements and marine hazards. A cool beach day can still be dangerous in the water. Do not assume the ocean is safe because the sky is not tropical. For the West Coast and California, preparedness means understanding the difference between unusual and solved. Cool air aloft, showers, and late-season mountain snow may be strange, but they do not erase long-term water concerns. Travelers in mountain areas should watch road conditions if snow is possible at higher elevations. Hikers should respect changing weather. Coastal residents should expect cooler, cloudier, breezier periods if the marine influence remains strong. For the Gulf Coast, the main message is flooding. Do not wait for a named storm to take water seriously. If repeated thunderstorms are forecast, keep checking local alerts. If a flash flood warning is issued, act quickly. Avoid low-water crossings. Never drive into flooded roads. Water depth is difficult to judge, especially at night, and moving water can carry vehicles away. Flooding is often the deadliest part of tropical and non-tropical rain events alike. The atmosphere does not need a named storm to create life-threatening water. For the Southeast, the message is balance. The rain may be welcome. It may help drought. It may begin improving soil moisture in some areas. But heavy rain can still create problems. Watch for runoff. Watch creeks and small streams. Watch urban drainage issues. Farmers and land managers should understand that rainfall may be uneven. Some fields may receive too much at once, while others receive less than expected. Drought relief is a process, not a single event. For Florida and the hurricane-prone coastline, preparedness means returning to the basics. Hurricane season is beginning whether the first storm forms now or later. That alone is reason to review plans. Know your evacuation zone. Know where you would go. Have supplies ready. Make sure important documents are protected. Check batteries, medications, water, food, pet supplies, and communication plans. But do not confuse normal readiness with immediate alarm. There is no reason to panic over an unofficial storm name. There is every reason to be ready for the season. This is especially important in the age of model screenshots. A single model image showing a storm days away is not a forecast. A single run showing landfall is not a warning. Forecast confidence comes from consistency, official analysis, ensemble support, and actual development in the atmosphere. The National Hurricane Center is the authority for tropical systems. Local National Weather Service offices are the authority for regional hazards. Emergency management officials are the authority for local protective action. Social media can help spread information, but it should not replace official sources. The best personal strategy is simple. Watch official updates. Understand your local risk. Prepare early. React only to verified information. That approach keeps you from ignoring real hazards and from being pulled into fake urgency. Preparedness without panic also means understanding your specific threat. Not everyone faces the same risk from this pattern. A person in North Dakota does not need to worry about a Caribbean tropical storm today. They need to worry about heat and fire danger. A person in Florida does not need to worry about plains fire weather. They need to watch rainfall, flooding, and tropical outlooks. A person in Boston does not need to prepare for 100 degrees under this setup. They need to understand cool, unsettled weather and storm chances. A person in California does not need to treat late-season mountain snow as drought ending. They need to understand the western upper low and local travel impacts. Good preparedness is local. The pattern is continental, but your actions depend on where you are. Still, one rule applies everywhere. Do not be passive. Weather patterns like this create problems when people wait too long to respect them. Heat becomes dangerous when people assume it is too early to matter. Flooding becomes deadly when people assume the road is safe. Fire weather becomes catastrophic when someone assumes one spark will not matter. Tropical misinformation becomes harmful when people share before checking. The atmosphere is already doing its work. People need to do theirs. And the work does not have to be dramatic. Move your outdoor work earlier. Clear drains. Avoid flooded roads. Follow burn restrictions. Check on someone vulnerable. Review hurricane supplies. Read the official outlook. Charge devices before storms. Know where warnings come from. Stay calm when thumbnails get louder. Small actions taken early are what prevent panic later. That is the point of this chapter. The pattern is unusual, but the response can be simple. Respect heat. Respect water. Respect fire weather. Respect official forecasts. Respect uncertainty. And above all, understand that no single headline captures the whole story. The first 2 weeks of June are not only about a possible tropical storm. They are about a blocked atmosphere shaping different hazards across different regions. The correct question is not, should I be scared? The correct question is, what does this pattern mean where I live? Answer that question and you are already ahead of the noise. Because panic follows rumors. Preparedness follows understanding. And now that we understand the pattern, we can return to where the story began. Not with Arthur, not with a cone, not with a named storm, with a shape. A shape already drawn across the atmosphere. A shape that may define the opening days of June. At the beginning, the internet wanted a storm. It wanted a name. It wanted Arthur. It wanted a dramatic satellite image, a landfall arrow, a headline, a threat that could be placed inside one word and understood instantly. But the atmosphere was telling a larger story. There was no Arthur yet, no official tropical storm, no confirmed depression, no organized cyclone spinning toward the coast. But there was something else, something bigger, a shape, a cold upper low in the west, a powerful ridge over the plains, a trough in the east, a moisture pump over the western Atlantic and the southeast. Together, those pieces form the pattern behind every major weather story unfolding across the country. The Omega Block, that is the real event. The storm may come later, or it may not, but the block is already here. It is already pushing heat into the plains and upper Midwest. It is already drying the air, lowering humidity, increasing fire danger, and making early June feel like deep summer in places that are not ready for it. It is already pulling cooler air into the northeast, delaying the feel of summer, keeping showers in the forecast, and reminding people that the calendar does not control the jet stream. It is already holding cold air aloft over California and the Great Basin, making the West Coast feel out of season and bringing the possibility of late mountain weather that looks dramatic but does not erase deeper water problems. It is already feeding a rain corridor across the Gulf Coast and Southeast, where thunderstorms can train, roads can flood, and water can become dangerous without a single named tropical storm. It is already beginning to crack the Southeast drought in some areas, but doing it through uneven, convective rainfall that can help one county and flood another. And it is already creating the environment that makes the Western Caribbean and Gulf worth watching as the Atlantic hurricane season begins. This is why the story cannot be told as separate headlines. The heat is not separate. The cool air is not separate. The California cold pocket is not separate. The Gulf Coast flooding is not separate. The Southeast drought relief is not separate. The Caribbean watch zone is not separate. They are all different faces of the same atmospheric machine. One pattern, many consequences. That is the message to carry forward. Because over the next several days, the headlines will continue to separate the story. One outlet will talk about heat. Another will talk about flooding. Another will talk about drought relief. Another will talk about the tropics. Another will show a dramatic model run. Another will ask if Arthur is forming. But if you know the shape, you can see through the noise. The Omega Block is the connective tissue. It is the hidden architecture behind the surface chaos. It is the reason America can feel like different seasons at the same time. And it is the reason the first days of June may become unusual, not for one single event, but for the combination of many. That combination is what people often miss. A 100-degree forecast in the northern plains is notable. Cool, unsettled air in the northeast is notable. Cold air aloft over California is notable. Heavy rain on the Gulf Coast is notable. Drought relief in the southeast is notable. A tropical development window in the western Caribbean is notable, but when all of them happen together, the story becomes bigger than any one region. It becomes a continental pattern, and continental patterns deserve attention. Not because every place will face disaster, not because every risk will verify at its worst, not because every model run should be believed, but because patterns like this create the conditions where impacts can compound. Heat over several days, rain over several rounds, fire weather over repeated afternoons, drought relief delivered unevenly, tropical uncertainty stretched across a moisture-loaded region, cool air lingering longer than expected. The danger is not always one dramatic moment. Sometimes the danger is persistence, the atmosphere repeating itself, the same ridge, the same trough, the same moisture feed, the same boundaries, the same vulnerable ground. Day after day, that is what makes a block different. And that is why the next thing to watch is not only whether a storm forms. It is whether the block holds. If it weakens quickly, the pattern may begin to relax. The heat may ease, the rain corridor may become less focused, the temperature contrast may narrow, the tropical window may become less favorable. But if it holds longer, the consequences can deepen. The heat can become more stressful, fire danger can remain elevated, flood risk can increase where soil saturates. The southeast drought relief can become more meaningful, but also more uneven. The Caribbean and Gulf can remain active enough for a disturbance to try organizing. The shape decides how long the story lasts. That is the final truth of this pattern. The name Arthur may or may not enter the record, but the Omega Block is already writing the opening chapter of June. Some people will remember this period as the week the heat arrived too early. Some will remember it as the week summer disappeared from the northeast. Some will remember the strange chill and mountain weather in the west. Some will remember flood alerts on their phones. Some will remember the first real rain after months of drought. Some will remember the online storm rumors before anything official existed. And if a tropical system eventually forms, many will remember that too. But underneath all of those memories will be the same atmospheric shape, the pattern that made them possible. So as June begins, watch the maps carefully. Watch the official outlooks. Watch the rainfall. Watch the heat. Watch the red flag warnings. Watch the western upper low. Watch the temperature gradient. Watch the National Hurricane Center. Watch the difference between hype and evidence. And most of all, watch whether the atmosphere keeps holding the omega shape. Because that shape is the real warning. Not a rumor, not a thumbnail, not a storm name before its time. A pattern, a blocked atmosphere, a continent split into different seasons. The storm everyone is naming may not exist yet, but the setup does. The pattern is already on the map, and until it breaks, the first days of June will belong to the block.